In this video, I'm going to give you an introduction to Amazon Bedrock. So once you're in the AWS console, there's a couple ways we can find Bedrock. Easiest would be come up to the search bar and just type in Bedrock and go ahead and click Amazon Bedrock to bring you into the Bedrock console. So once we're in here, if you expand the left-hand side, you'll see all the different areas. So you'll see our foundation models, playgrounds, the knowledge base under orchestration, and under assessment and development, we have model evaluation and provision throughput. So let's take a look at some of these pages that we can view, starting with examples. So if I select examples, you'll see a lot of different examples here. So you can action items from a meeting transcript, advanced Q&A, and it shows you as well what model it's using. So this one is using Titan Text G1. This one's using Claude. Chain of thought would be Llama 2 chat, right? You could do character role play. So these are just examples that you can potentially use. So I can select one, I can come down and I can open it up in Playground. So if I select open in Playground, here's where I can play around with it. Here's a sample meeting transcript. Then I can come over, I can turn up my temperature or my top P or my length. And I can expand model metrics here. And if there are any metrics, I would see these here, right? So I can go ahead and click run here, and it's running through, and it's going to create a list of action items. So McGill has to document any concerns. Brant has to work with James from another team to unblock the sign up workflow, and Namita works on the landing page. So you can see the difference here. I can change temperatures and whatnot, but it's a good place to come and see your actual base models that you can use. And some of these models will allow you to play around and kind of get a little more familiar with them. Now you can see that the metrics are populated. You can see the latency, the input and output token counts, and the cost to run it. Right, so there is a cost to these as well. So that's your examples and that's your playground. Right? If we come down and select under providers, we can also see all the foundation model providers that we can use. So we can scroll across the top. We have all the providers. And once you select one, you can see all the different foundation models and you can open those in Playground as well. So if we select Amazon, you'll see Amazon Titan. Anthropic, we'll see Claude 2. If we go to Cohere, we'll see the Cohere examples and some of the models. They're Command, Command Light, Embed English, and Embed Multilingual. You can go through Meta. Stability AI also has some as well. Right, so these are your model providers. All the providers have examples, and you can view more about the models and the end license user agreement. If we come down under foundation models and select base models, you'll see those same models, but now they're actually grouped by the type of model they are and not by the actual provider. So you have Claude version 2. We have Cohere. We have Embed by Cohere. So this gives you an ability to look at the provider details and you can look into it a bit more, see what it's used for, see who provides it. The token availability is there as well. Under custom models, if you were to customize your own model, you can do that here. So you can select customize model and you can create either a fine-tuning job or a pre-training job. From here, we got our playgrounds again. So we just looked at the chat playground earlier. Now we're going to check out the text. So I can select my model. You see all the text models here. I can select one and I can apply it and I can open it up in the playground. Right, so it's just an easy way to kind of get a good idea and demonstration on these models. Chat we looked at and images here as well. From here you have your knowledge base and any agents. So if you select agents, agents allow you to deploy an agent version in your application, and therefore you can use Bedrock in your custom applications. So I hope this video showed you some of the capabilities of Amazon Bedrock, whether it's examples or the different providers of the use of the playground. but hopefully it gave you some insight onto Bedrock, how to use Bedrock, and hopefully will start your journey with Amazon Bedrock. In this video, I'm going to show you how to build a GAN architecture using Amazon SageMaker and Jupyter Notebooks. So once you're inside the AWS console, let's come up to the search bar and let's just type in SageMaker. And this will bring us into the SageMaker console, and this is where we can create our notebook instances. So let's go down on the left hand side, let's find Notebook, and then let's find Notebook Instances. From here we need to create a notebook instance. This is allowing us to utilize Amazon SageMaker, and SageMaker can spin up these Jupyter notebooks and we can perform creating our GAN inside there. We can pre-process the data there. We can train the data there as well. So it's all going to be done inside a Jupyter notebook. So let's come up and click Create Notebook Instance, and let's give it a name. I'm going to call mine Richard Demo. I'm going to leave the instance type to ml.t3.medium. So that's machine learning, T3 medium. And the platform is going to be Amazon Linux 2 with Jupyter Lab 3 already on it. Permissions and encryption. I already have an IAM role, but if you don't, you can select the drop down, select Create a New Role, accept all the permissions, and click Create Role, and it'll pre-populate it for you. Everything else can stay the same. Go ahead and click Create Notebook Instance. This will take a few minutes to spin up your notebook. It'll go from pending, but once it's in service, then you can go about using your Jupyter notebook. So we want to create that GAN, that Generative Adversarial Network. And that's a deep neural network architecture, and it consists of a generator network and a discriminator network. The generator will synthesize the data and try to deceive the discriminator. On the flip side, the discriminator is going to authenticate the data and then try to correct and identify all the synthesized data. So in the process of training iterations, the two networks continue to evolve and confront one another until they reach an equilibrium state, until they agree on everything. The discriminator can no longer recognize synthesized data anymore, at which point the training is over. So we need to get that GAN architecture up and running. All right, so we need SageMaker, which is a fully managed machine learning service. It allows us to mainstream these frameworks like scikit-learn, XGBoost, TensorFlow, and PyTorch. And with SageMaker end-to-end functionality, we can focus on model building and easily train a variety of GAN models. So in this video, we want to set up that GAN architecture. As soon as our notebook instance is in service, we can begin to set that up. So a couple minutes and you should be ready to go. So now we have our notebook instance created. Go ahead and click Open Jupyter Lab. And here inside Jupyter Lab is where we can do all of our work. The first thing we need to do is set up this development environment. So we're going to download the source code for this example. So I want you to come up under Git, and I want you to click Clone a Repository. And we're going to type in https://github.com/amazon-sagemaker-examples.git. Go ahead and click Clone. So now you'll see a folder here called Amazon SageMaker Examples. If you open it, we want to go into the Advanced Functionality folder, and we want to open up the PyTorch Bring Your Own GAN. So PyTorch Bring Your Own GAN, we're going to go ahead and we're going to open it. You'll see the Jupyter Notebook here. Build GAN with PyTorch. Let's go ahead and open it. Now it's asking us for the kernel. I want to choose the newest PyTorch. So PyTorch 310 and click Select. So this is a walkthrough to get that GAN up and running and ready to go. So the first thing you'll see, and if you've never used Jupyter Notebooks before, all of these cells can be run just by clicking Shift and Enter on your keyboard at the same time. So let's start with our environment setup. Let's go ahead and upgrade our packages. You'll see it's doing a pip install, and it's going to upgrade SageMaker the AWS CLI, Bodo 3, NumPy, and IPY widgets. It's also going to install Pillow version 7.1.2. So go ahead, Shift and Enter. You'll notice in between the square brackets you have an asterisk. That means that it's still running that command. When that command is finished, you'll see a 1 there. All right, so right now it's going through and it's doing our upgrades. Now you can see it changed to a 1, so it's complete. We have our upgrades here. Let's go all the way down. You see all the output. Now we're going to create some folders. So we're going to make a directory. We're going to make a data directory, a source directory, and a temp directory. Let's go ahead and hit Shift Enter. You see the asterisk. It's doing something. Now it's 2. It's done. Now we want to download our data. A lot of different public data sets that we can use online. We're going to use the MNIST data set. And this is handwritten digits data set. And we're going to use that data set to train a GAN model and eventually generate some fake handwritten digits. So we're going to import Bodo 3. And from SageMaker.s3, we're going to import the S3 downloader. And that allows us to download from S3. So go ahead, Shift Enter. It's going to go out and grab that file for us. And you can see right now the URL. And it's datasets image MNIST/PyTorch. So you see some info here. All right, now you can see that it's done. It grabbed that data for us. So I hope this video showed you how to set up a GAN architecture. Now if you keep all this together, it'll flow nicely with our next video when we talk about data preparation, and finally the video after that when we get into training. So continue to use this notebook instance, and it'll save you a lot of time from having to repeat these steps again. But again, I hope this video showed you how to set up SageMaker, Jupyter notebooks, bring in that training data, and set up that GAN architecture. In this video, I want to talk about how to pre-process and prepare data for training generative models in SageMaker. So this video will continue from the last video. If you remember, in our last video, we set up SageMaker and Jupyter notebooks. We set up our environment and all the architecture. We updated everything that was on our Jupyter notebook. We downloaded our data, which was the MNIST sample data. And now we're going to prepare that data. So the PyTorch framework, which what we are using, has a package that has access to several data sets. It's called torchvision.datasets. We're going to run this command now to read that MNIST pre-downloaded data set from our local storage so that we can use it later on down the road. So you'll see we're saying from torchvision import datasets. We're setting our data root to our .data directory. We have a train set and a test set variables, which we're setting as datasets.mnist. We're passing in our root, being our data root, ./data. Train equals true for the training set. Train equals false for the test set. And download is false on both. Then we're going to print the train set and we're going to print our test set. So let's go ahead and hit Shift Enter and let it do its thing here. So we're just reading in data from the data set that we downloaded in the previous video. Once it's complete, you can see the printout. So you can see for the training set, we have a number of data points is 60,000. We have its root location as .data, and the split is train. We also have test data as well, which is also located in the data folder, and it has 10,000 data points. And this is up here. If you notice data, you can view MNIST. You have your process data and raw data. So you can always see your folder structure over on the left-hand side. So now we want to create an S3 bucket so we can access our files and data. We may need that down the road in our machine learning lifecycle. So go ahead and hit Shift Enter here. You'll see from SageMaker.session, we're going to import session. We're going to create a bucket with a prefix. We're going to give it a location to save our custom code and a location on where the results of the model training are saved, because they're not going to be saved in the exact same spot. All right, it'll be in the same bucket, but one's going to be in custom code, the other is going to be in artifacts. Go ahead and hit Shift Enter, and it'll create that for you relatively quickly. The last thing we're going to do here is create a variable called S3 data location, and we're going to use some tools that SageMaker provides for interacting with AWS services. So this S3 downloader class, we can use that to download objects in S3, and conversely, S3 uploader will allow us to upload local files to S3. So we're going to upload the dataset files to S3 for model training. And that means that we don't have to download that data from the internet, and therefore we can avoid all the latency that goes with fetching data from the internet. And at the same time, we're avoiding security risks as well, because we're keeping everything contained to our AWS environment. We're not sending a bunch of data out over the internet. So let's go ahead and hit Shift Enter. And from here, it's just setting that data location. And now it's all done. So now all of our data can be uploaded and downloaded through the AWS network and not have to be sent over the public internet. So let's go take a quick look at those S3 buckets. So I'm back in my AWS console. Let's type in S3. And we're brought into the S3 console. I have a lot of buckets, so I'm going to have to search by creation date. And you'll see January 2nd, 2024, SageMaker-US-East 1. Go ahead and select it. You'll see BYOS, PyTorch GAN. And here we have our artifacts, our custom code, and our data. So right now we have our MNIST data. It's processed and raw. Exact same file structure we have in our Jupyter Notebook. If we come back out again and we go into custom code, here's any training code, right? We can open up these folders. We can see the source, and they're all tar.gz files, so we can download them. They're all going to be compressed. And if we go into artifacts, you'll see the same thing. Any artifacts, if there's any debug output, profiler output, or any output, these models are all here as well. So you'll start seeing these once we actually run our training on our models. But I wanted to show you how we can prepare that data, how we can use our environment to avoid sending data out over the internet, and utilize Amazon's network and Amazon S3 to get that data pre-processed and prepared for training. In this video, I'm going to utilize SageMaker's built-in algorithms for training generative models. And this is going to piggyback off the last two videos. If you remember, we created that GAN architecture. The last video, we prepared and pre-processed some data. Now we're going to get into training that model. So let's look at the code that we have to work with here. So the first thing we're going to do is do some imports. So the scripts start by importing necessary libraries, and it sets up some configuration like logging and CUDA if it's available. From here, we begin our class definitions. So first thing we do is define our generator. And a generator is the generator neural network, and it's going to use transposed convolutional layers to generate images from random noise vector. We also have a class for our discriminator. This uses convolutional layers to classify images as real or generated. So remember, those generator and the discriminator play against one another. We also have a class for DC GAN. This is a wrapper class that contains methods for training the generator and the discriminator model. So we put in things like fixed noise equals none, criteria equals none. All right, so these are our class definitions. Next, we have some functions. So we're going to have functions starting with weights in it. So this initializes the weights of the model for better convergence. Log batch logs the training process for each batch. We have a function called getDevice. Use CUDA, and that determines if CUDA is available and sets the device accordingly. We have a function called train. So train, this is the main training loop, and it iterates over the data set and updates both the generator and the discriminator. We have functions for saving and loading the models, and we have a function for parsing arguments. So this parses the command line arguments for various training parameters. If we scroll down, we have a function called getDatasets, and this prepares that MNIST dataset for training. The script then pre-processes command line arguments and sets up the data directory. Then we get into the actual model initialization and training. So if name equals main, right, this is where we want to perform our training. It initializes the DC GAN model with the specified hyperparameters. As you can see here, it's going out and getting those hyperparameters. It sets the random seed for reproducibility. It configures the data loader for the data set, and it calls the train function to start the training process. And here's the train function here. So if we hit Shift Enter, this will run. It'll take a few minutes because we're actually running a training model here. So be patient, give it a bit of time, and once this asterisk changes to a number all the way up here, then we'll know that it's been completed. And it is, it's 7. Next, we're going to get the execution role. Now we're going to bring in those hyperparameters that are used in the model training tasks, and they're going to be passed in when the training task is created. So go ahead and hit Shift Enter. We've imported those hyperparameters. And now we're going to use PyTorch, and we're going to actually run the training. PyTorch is an estimator for the PyTorch framework, and we're going to use it to create and execute training tasks as well as deploy trained models. So in this list, we have an instance type that's used to specify the instance type. Is it a CPU? Is it a GPU? All right, so go ahead and click Shift Enter. You'll see we have our role, our entry point, the source directory, our instance type, our framework version, and so on. Then we can come down and start the training. So you can see from SageMaker.estimator, it's importing estimator. And this is an object that represents a machine learning model or algorithm. An estimator will abstract that complexity of training a model by encapsulating the details like what type of model it is, its parameters, and the environment that it's using. Next, you'll see the estimator.fit. This is a method that's called on the estimator object. The fit method is a standard term in machine learning that means to start the training process. So when you invoke fit, you're telling the estimator to begin training a model using the data and the configuration you have specified. MNIST and the S3 data location is the data source for training, and the fit method needs to know where to get the training data from. In this case, it's from a data set labeled MNIST, and it's in an S3 bucket. Weight equals false. So this parameter determines the behavior of the script once the fit method is called. If weight is set to true, the script will pause and wait for the training job to complete before moving on to the next line of code. If weight is set to false, as in our example, the script will initiate the training job and then immediately proceed to the next line of code. So in summary, this is a command to start training a machine learning model on the MNIST dataset. So let's go ahead and hit Shift Enter. You'll see some info. Don't let the red scare you. It's not an error. It's just an info. Now we can move on to our next cell. And that's because we had weight equals false. So that detaches the notebook from the training task, and we can continue to use the notebook. So now we're going to run another command. And this command starts with %% and then says from SageMaker.estimator import estimator. So this time is a magic command specific to Jupyter Notebooks. Magic commands are enhancement that Jupyter Notebooks offer beyond standard Python syntax, and they're prefaced with 1 or 2% signs. When placed at the top of a cell on a Jupyter Notebook, it measures the execution time of the cell's contents and provides a simple and convenient way to time how long the code in the cell runs. Next, again, we import our estimator. Then we have our training job name. equals to estimator.latest training job name. So here, estimator is presumably an existing instance of an estimator that we used previously. The latest training job is an attribute of estimator, and the name is then used to extract the name of that latest training job. So if we go ahead and hit Shift Enter, so this will import necessary classes from SageMaker, retrieve the name of the latest training job from the existing estimator, and then attach this to a training job to create a new estimator object that reflects its configuration and state. So it's still running. It can take a little bit of time for this to finish, but when the training completes, the trained model will be uploaded to Amazon S3. You can see it prepared the instances for training, downloading the training image. Training image has downloaded, and now training is in progress. Now you can see that it's uploading the generated training model. Shouldn't take too much longer, and it's complete. So it was 7 minutes and 34 seconds. And now you see it's done because you see the number 12. So now we just want to verify that model. So let's go and download the trained model from S3. Hit Shift Enter. Hit Shift Enter. And now we're going to execute these instructions to load the trained model and generate a set of handwritten digits. If we get our handwritten digits, we know that we successfully trained that model. So let's go ahead and hit Shift Enter. And let's hit Shift Enter again. And now you can see we set a variable called img, and we called the generate fake handwriting. So it's not completed yet, and now it is, and we can see it. So I hope this video showed you how to train a model using the built-in training opportunities that you have available to you in Amazon SageMaker and Jupyter Notebooks. In this video, I'm going to show you how to train a generative model using SageMaker's distributed training capabilities. So the first thing we need to do is go into SageMaker. So up under the search bar, if I type in SageMaker, I can go ahead and click and get brought into the Amazon SageMaker console. On the left-hand side, let's come down to Notebook and Notebook Instances. Once we're here, go ahead and click Create Notebook Instance. And let's give it a name. So I'm just going to call it Distributed Demo. And the notebook instance type should be ml.p3.16 extra large. So go ahead and select it. Everything else you can leave the same and click Create Notebook Instance. So it's now pending. Eventually it'll get into in service, and from there we can go about using that notebook instance to do our distributed training. And now we're going to be brought into our Jupyter Lab instance. So Amazon SageMaker's distributed library can be used to train deep learning models, and it can do it a lot faster and a lot cheaper. So with this video, you have some code. There's two files. One's called code.txt, which will have all the code that we're going to input into our notebook. And there's also a data set there as well. And that ends in .py. This example we're going to use uses the MNIST data set. And that's widely used data set for handwritten digit classification. It consists of 70,000 labeled grayscale images of handwritten digits. So we want to go ahead and we're going to use Conda PyTorch P310. So the first thing we want to do is do an upgrade. So if we do pip install SageMaker -- upgrade, hit Shift Enter, just like in the previous videos. If this is an asterisk, it's still running your command. Once that changes to a solid number, it's complete. This command is used to upgrade the Python SDK, and import SageMaker imports the SageMaker module, and that's necessary for interacting with Amazon SageMaker. As you can see now, it's turned to 1, so now it is complete. The next thing I want to do is bring in our data set. And if you find that data set, you can just go ahead and drag and drop it. So I'm going to go into my computer. You'll see the train TensorFlow SM data parallel mnist.py. So come back and drag it into your Jupyter notebook. And once there, we're going to create a new folder called code. And I want you to drag that py file into code. So now we can actually work with that data. So the next thing we want to do is based around IAM roles. So the following codes that we're going to put in now will define a role variable, and that's the IAM role that's used to create and run SageMaker. So let's come down to our next cell, paste it in, and you can see what it's doing here. SageMaker session is created to establish a connection to the SageMaker services, and then role is obtained using the get execution role. So we hit Shift Enter again. It'll go through and get that role for us, and then we can use it. Once it completes, you should see the number 2. Now it's done. You see some info, but no error messages. The next thing we want to do is the source code inspection. So this references Pygmentize code train TensorFlow SM data parallel. That's why we had to create the code folder, because when we run this command, we need to show where that py file is. This line executes Pygmentize, which is used to view the contents of a Python script. And this is the Python script that we're passing in. And it's a way to inspect the code within the script file. So if we hit Shift Enter, you can see we're looking at all the code. Everything seems to be. So what's next? Next, we need to create the SageMaker TensorFlow estimator. So I'm going to copy in the code, and we're going to take a look at what it does. So we got a lot of different parameters we're setting here. Base job name is just a prefix for the name of the SageMaker job. Source directory is the directory where the training script is located. And as you can see, it says code. Entry point is the Python script. Role is the IAM role. PY version is the Python version we're using for training. Framework version, so that's the TensorFlow version used for training. Instance count is the number of training instances. In this case, we have 2, and that indicates distributed training. The instance type, the SageMaker session, and distribution. So in order to use DDP mode, you update this distribution strategy. And we enable data parallel. So now we have distributed training. So go ahead and hit Shift Enter. It runs. Doesn't take very long at all. Now we're going to actually do the training. So the next is estimator.fit. And the fit method is called on the estimator. And this initiates the training process for the machine learning model. So go ahead and hit Shift Enter. You get a bit of information, but it's creating the training job. And this may take a bit of time. So be patient. And when it's complete, we can store that model data and run some inference against it. Now it's preparing the instances for training, so it takes care of all that for you. So now it's downloading the input data. Once it downloads the input data, it downloads the training image. Now the training image has downloaded and the actual training is going on in the back end. Now you can see the model's trained. All your information is here. A lot of output information. There's a lot going on during the training of that model. Your training seconds are here, 606 seconds. I also have billable seconds, which are also 606 seconds. So I hope this video showed you how to do distributed training with Amazon SageMaker and Generative AI. In this video, I'm going to optimize and fine-tune generative models in Amazon SageMaker. So once we're inside the AWS console, let's come up and type in SageMaker, and let's go to the SageMaker console. Now, this video is shortened due to editing, but this can take up to an hour. So we're going to run some tuning that can take up to, say, 30 to 45 minutes. You factor in creating a notebook, and you're looking about an hour. So make sure you tear down everything after we're finished. So the first thing we need to do is create an instance. So let's go down to Notebook, go into Notebook Instances, and create a Notebook instance. So I'm just going to call this Richard Demo, and I'm going to use ML M5 extra large. So let's go ahead and come down. Everything else can stay the same, and let's create the Notebook instance. So while this is firing up, let's actually talk about what we're going to do. So we're going to use hyperparameter tuning in this case. We know that selecting the right hyperparameter values for our machine learning model can sometimes be hard. And the right answer really depends on our data. Some algorithms have many different hyperparameters that you can tweak. Some are very sensitive to the hyperparameter values that are selected, and most have a nonlinear relationship between model fit and hyperparameter values. Hyperparameters are just parameters whose values control the learning process and determine the values of model parameters that a learning algorithm ends up learning. So this is configuration that's external to the model and whose value can't be estimated from the data. They're often used in processes to help estimate model parameters, and they're often specified by the practitioner. They can often be set using heuristics, and they're often tuned for a given predictive modeling program. So we're going to tune an image classifier, and we're going to leverage the automatic model tuning. So once your instance is ready, it'll say ready in service, and you can go into the Jupyter Notebook. So we'll just give this a minute, and then we should have a notebook instance ready to use. So now that our instance is ready, let's go ahead and select Open Jupyter Lab. With this video, there's a file. It has the extension IPYNB. This is a Jupyter Notebooks file. We're going to bring that file into our Jupyter Notebooks instance, and we're going to run the commands from there. We're going to talk about it and see how we can fine-tune these hyperparameters. So I'm going to go on my hard drive where the file is, and I'm just going to pull it over into my Jupyter Notebook instance. Go ahead and double-click it. It's going to ask you what type of kernel you want. We are going to go with Conda Python 3 and select. So the first thing we're going to do is import SageMaker, get our execution role, import things we need like Bodo 3, which is the AWS SDK for Python. Then we're going to assign a value to role, and that's going to retrieve the IAM role. We're going to create a SageMaker session, which manages the interaction with the SageMaker services. We're going to set our buckets and our prefixes. So go ahead and hit Shift-Enter. Again, while it's an asterisk, it's doing something, and you can't run any more of these cells until the one above it is finished. And when it's finished, it'll show you a number instead of the asterisk. So let's just give it a second here. So now it's completed. There's a couple info messages, CPU times, wall times. Now from here, we're going to do our image classification training image retrieval. So we're going to, from SageMaker.image_URIs, import retrieve. This is going to import a function to get the URI of a SageMaker Docker container. And that's going to retrieve the Docker container image URI for the SageMaker built-in image classification algorithm. So Shift-Enter, again, does it very quick, prints it out. Now we're in the data preparation. So we need to download the data and transfer it to S3. So we're using Caltech-256 dataset. This has 30,608 images of 256 objects. So let's go ahead and run it. It'll take a second here. It's going out and it's getting both the training and the validation data sets. As you can see here, train.rec, val.rec. So train.rec just downloaded, and we're working on the validation data set. Now we have it. We're going to upload it to S3. So we have 4 channels. We have a train channel, a validation channel, a train list, and a validation list. So let's go ahead and hit Shift-Enter. This will take a couple minutes, and this is going to construct our S3 URLs for storing our data. Now we have to set our data channels. So we're setting our S3 output location, we're setting our input training data, and our input validation data. We're just specifying where we can go and find it. So we hit Shift Enter. It's done very quickly. Now we're getting into the real under the hood stuff. We need to set up our hyperparameter tuning job. We've got the data set already. Everything knows where to find the data. Now it's time to set up that hyperparameter tuning job. So before we launch our tuning job, we need to configure the training jobs the hyperparameter tuning job is going to launch. So let's take a look at some of these before we actually begin that training job. So we have to specify our hyperparameters right here. So we're setting our hyperparameters. So you can see that we're creating an instance of the session class from the Amazon SageMaker Python SDK. Then we go into image classification. So this section of code is creating an estimator object for the image classification task. So you have training image. This is the URI of the Docker container that contains the image classification algorithm. Our role, instance count. So how many EC2 instances are we going to use for training? The instance type is here as well. Then we have our output path to S3, where the results of the model training is going to be stored. And we have our SageMaker session. So that indicates the estimator should use the previously created session that we created above. Now we get into setting our hyperparameters. So num layers equals 18. This is a number of layers in the neural network. 18 is a moderately deep network. Image shape equals 3,224,224. This is the dimension of the input images. 3 refers to the number of color channels, RGB, and 224 is the height and width of the image. Number of classes equals 257. So that's the number of output classes for the classification task. So the model will classify images into one of 257 different categories. Num training samples equals 15,420. This is the total number of training samples in the data set. Mini batch size is a subset of the training data set and is used to calculate the gradient and update the model in each step of the training. Epochs equals 10. This is the number of complete passes through the entire training data set. Optimizer equals SGD. SGD stands for stochastic gradient descent, and it's a popular optimizer in neural network training. Top K equals 2. This refers to a metric used during evaluation, such as the model's ability to place the correct label within its top 2 predictions. Precision D-type float 32 sets the precision of numbers used in training. So this is a precision floating point, and this is very common for neural networks. And augmentation type equals crop. So that specifies the type of data augmentation to be used. Crop suggests that the image will be randomly cropped as a form of augmentation. So together, these configurations set up a SageMaker training job for an image classification model. And that's where hyperparameter tuning comes in. We can change these if we want, right? We're not. We're going to leave it as it is, and then we're going to run our tuning job. So go ahead and Shift Enter, and it's done very quick. We set these variables. Now we're going to go down and actually set up our tuning job. So we have an import statement. We're importing specific classes from SageMaker.tuner module. Things like integer parameter, categorical parameter, and continuous parameter are classes used to define ranges of hyperparameters that the tuning job is going to explore. Then we actually set our hyperparameter ranges. So learning rate is a key hyperparameter in many optimization algorithms, and it controls the step size at each iteration. Momentum is often used in conjunction with SGD. And momentum helps accelerate the optimizer in the right direction. And weight decay, and that's a regularization parameter to prevent overfitting by penalizing large weights. And this range is usually set from 0.0 to 0.99. Then we have our objective metric name, so validation accuracy. And this specifies the metric that the tuner will use to evaluate the model's performance. Then we get into hyperparameter tuner configuration. So tuner equals the hyperparameter tuner class, and within that we have all of our objects. So we have an image classification object that defines the model to be tuned, our objective metric name, that is the metric that the tuner will optimize for, hyperparameter ranges, objective type equals maximize, that specifies the goal of the tuning job is to maximize the objective metric, which is accuracy in this case, max jobs, and max parallel jobs. So let's go ahead and shift enter. Now we're going to launch our hyperparameter tuning job. So the tuner.fit method is a crucial part of using SageMaker's hyperparameter tuning functionality. It starts the actual process of hyperparameter tuning by running multiple training jobs with different hyperparameter combinations. So tuner refers to the hyperparameter tuner object that we created earlier. And fit, this is a method on the hyperparameter tuner object that starts the hyperparameter tuning process. So then we pass in some parameters of fit. We pass in our training data, we pass in our validation data, and we don't want to include any metadata. This command is going to take about 35 to 40 minutes. So go ahead and hit shift enter. You'll get those couple infos, but this will continue. And while we're doing this, we can go over into the SageMaker dashboard and take a look. So once we're back in SageMaker, if we click SageMaker dashboard, we can see that I have one notebook instance, there's 2 training jobs running, there's 1 hyperparameter tuning job running, and there's 1 endpoint in service. So if we click on training jobs that are running, it'll show you the ones that we just set up our image classification. So give this about 30 minutes, and then when it's done, we can take a look at what it accomplished. So now it's finished. You can see the exclamation point, and the number have changed to 8. Now we want to analyze the results of that hyperparameter tuning job. So let's bring in a table of metrics. And now you see our metrics. You see the learning rate, the momentum, the weight decay, training job name, 5 different, the status, the final objective value, and how much time elapsed for each one. So you see your learning rate, that's used in each training job, and it's a crucial hyperparameter in machine learning because it affects how much the model's weights are updated during training. A smaller learning rate might lead to slower convergence, while a too large learning rate can cause the model to overshoot the minimum. Now we can analyze these results a little bit deeper. We're just going to print out a plot and show how the objective metric changes over time as the tuning processes. So I'm going to change plot width to just width and plot height to just height. Shift enter, and once it's finished, we can take a little look here. So our resulting chart is a scatter plot where each point represents a training job from the hyperparameter tuning process. If we go up, we saw we had 5 jobs, and we have 5 dots on our scatter plot. X-axis will show the start times of the jobs. The Y-axis will show the corresponding final objective value, and in our case, that's accuracy. And this will help quickly identify patterns or trends in how the training jobs performed over time. So I hope this video showed you how to fine-tune your hyperparameters in your generative AI training models. Currently, the field of natural language processing is being led by advanced large language models, and they have billions of parameters. These LLMs are transforming how we approach various language-related tasks like text generation, sentiment analysis, language translation, and more. Thanks to their access to extensive data, these models hold the potential to fundamentally change our interaction with language. While they're versatile in handling different NLP tasks, these models are more like jack-of-all-trades rather than specialized experts. Specialized training or fine-tuning is often necessary to make them proficient in specific areas. One significant issue with these massive LLMs is their enormous size, and that poses a challenge in terms of training and deployment. Fitting them into standard GPUs, which are typically used for deep learning tasks, is not feasible due to their size. So to manage these large-scale models, High-end computing resources like specialized GPUs with substantial memory are required. Moreover, their size also means that these models are continuously computationally demanding, leading to increased costs and longer times for both training and using these models. So in this video, I'm going to demonstrate how we can use SageMaker Jumpstart to easily fine-tune a large language text generation model on a domain-specific dataset in the same way you would train and deploy any model on Amazon SageMaker. So I'm going to show you how to fine-tune the GPT-J6B language model for financial text generation. So we're going to use Amazon SageMaker Jumpstart. So once you're in the SageMaker console, you can go ahead and click on Studio. Now, if you've never used Studio before, you will have to create a domain. Just a couple clicks, and it'll create the SageMaker domain for you, and then you'll see your user profile here. So I'm going to go ahead and click Open Studio, and that brings me into the domain I created and brings me into SageMaker Studio Home. So once we're here, let's come down to Jumpstart, and here's where we can see some of the different models. So we want to look for the GPT-J6B model. So let's come up under Hubs, and let's just type in GPT-J, and you'll see GPT-J6B. This is our text generation model, and this is the model that we want to train on specific financial data. Go ahead and select it. Gives you a bunch of information about the model itself. All right, we have options here to train, deploy, or evaluate. We want to train it. We want to train this model on financial data. Go ahead and click Train, and now we can see exactly where we can put in some of this information. So the model artifact location, it's right here. It's in the S3 bucket that Amazon created for us to hold this model. Now the data, so the training data set. So we have a default training data set location, and you'll see it right here. So this is the SEC filing data set. SEC filings are used for regulation and disclosure in finance. The text in these SEC filings covers the whole group of companies' operations and business conditions. So because of their potential predictive value, these filings are actually good sources of information. So using the SageMaker API, we're going to download these annual reports for a large number of companies, and we're going to use that to fine-tune the GPT-J model. So it's already there. If we had another data set that we wanted to use, we could enter it here. I'm just going to go with the default. So this is the SEC data we're going to use to fine-tune our model. All of our hyperparameters are here, so we can change these if we wish. So our epochs, or how many times the original data set is going to be iterated. Our learning rate controls the step size or the learning rate of the optimization algorithm. Eval steps specifies how many steps to run before evaluating the model. Weight decay controls the regularization strength during the model training. We can come down and click Show More, and we'll see a bunch of different ones here. Evaluation strategy will be the evaluation strategy used, and so on. So these are all of our hyperparameters. We come down, we have deployment. So what instance setting do we want to use in a training job? We're going to go with an ML G5.12 extra large. We're going to specify our output artifact location. Any security, I'm just going to leave it all with the default IAM role. No VPC, default encryption. And we have our training job name here. I can put Richard Demo on the end just to make sure that I can recognize it. And I'll go ahead and click Submit. And now this is going to execute. May take a little while, so we'll come back and we'll see what we've accomplished once it's all finished. Now you can see that the job is completed, how long it ran. All right, so let's go over to CloudWatch Logs. I want to show you one more thing. So I'm going to go over to CloudWatch Logs, and under Log Groups, I want to type in SageMaker, come down to Training Jobs, Then we're going to find the training job that we just did. So you can tell by the last event time, it's January 31st, and it has Richard demo. So I'm going to select that log stream, and now you can see all the logs from this fine tuning job. So if we come down, you'll see everything that was done. But the main one I want to show you is what they call perplexity. So I'm going to come down right to the end. It's a lot going on. There's a lot of logs here because there's so much going on with these training jobs. But I want you to find the one that says eval metrics and go ahead and expand it. You can see the perplexity now is 4.86. So perplexity is emitted in the training jobs CloudWatch logs, and the lower the perplexity, the better it is. So after you fine tune, that perplexity should be down. And in the beginning, that perplexity was around 8. Now we're at 4.8. So it's more fine tuned to the SEC data. So from here now, you can run jobs against different data, different financial data, and you should get much better outputs because of the training that you did on this specific model. So I hope this video showed you how training to a specific type of data or a specific industry can increase the output from your models for future training jobs. In this video, I'm going to show you how to evaluate the quality and diversity of generated content using some appropriate metrics. So once you're inside the AWS console, let's come up and type in SageMaker, and let's go into the SageMaker console. So from here, we're going to come down to Notebook, expand Notebook. Let's click Notebook Instances, and then let's create a Notebook instance. So I'm just going to call this Metrics Demo. I'm going to leave the instance type as a ml.t3 medium. A small instance type is fine for this demo. I'll leave everything else the same, and I'm going to click Create Notebook Instance. This will take a couple minutes to fire up, and when it does, we can go into Jupyter Labs and check out some metrics and see how our models are actually performing. Now you can see that is in service. Go ahead and click Open Jupyter Lab, and that'll bring us into our Jupyter Lab notebook where we can go about evaluating these models. So the first thing we want to do is choose a Conda Python 3 notebook, and then once we're in, we want to update the notebook. So we're going to do a pip install. We're going to install transformers, torch, and scipy. So shift enter, we'll run it. Once it's finished, the asterisk will turn into a number, and then we can move on. It's going to take a couple minutes. There's a lot of stuff it needs to download and update. Okay, now we can see that it is complete, and we can carry on. So we want to generate some content. So we're going to assume that we're going to generate some text using a pre-trained model from Hugging Face. We've used Hugging Face before. So here's a little bit of code that's going to allow us to do that. So I'll paste in my code. You should already have it when you have this notebook file that come with this video. So I'm saying from transformers, and that's the transformers library in Hugging Face, import pipeline. Then we want to load a pre-trained text generation model. So we're saying our generator is the text generation, model is GPT-2. And then we're going to generate text, and we're going to store it in a variable called generated text. So we're going to run the generator. We're going to say the key to being a successful Fisher person. And this code should generate 10 pieces of text with that prompt, the key to being a successful Fisher person. From there, we're going to evaluate the quality and the diversity. So let's go ahead and run it. Doesn't take very long. So you can see that it's going through. You will see a couple error messages here. They're not exactly error messages. They're just info messages talking about how our truncation was not explicitly activated. But max length is provided as a specific value. So you can ignore all that. It'll go through. It's doing its thing. And then once it's done, we can actually see what it gave us. And then we can check out the diversity and the perplexity. So now you can see it's completed. Let's go ahead and let's print our generated text just to see what it gave us. So we can see here that we have 10 different text prompts. The key to being a successful fisher person is your ability to harvest and save, like I did, and then there's some gibberish for the last one, and your willingness to share that with your fishing partners. You can be a fisherman for a family or a community. Then we get the next one. The key to being a successful fisher person is to learn where to eat and then follow them on. There's still plenty of meat available. Sushi is the goat. You just go with the flow. Fish are an excellent source of. And then it just stops. So there's 10 of these, okay? Now let's take a look and see the quality and the diversity. Quality can be subjective, but for text, we're going to evaluate grammar, coherence, and relevance. So we're going to calculate perplexity. All right, we have a function here to calculate the perplexity, and then return the perplexity, and then we're going to take a look at those scores. So Shift-Enter, we let it run, and now we have all of our text from 1 to 10 broken down with perplexity. So how do we understand perplexity? A lower score means the model predicts the sentence more confidently, so it's higher quality. Now, it's important to note that perplexity alone doesn't capture grammatical correctness, relevance, or creativity. It's more about how well the text fits what the model expects based on its training. So a lower score should be more coherent. So our first one is 22.44. The key to being a successful fisherman is your ability to harvest and save, and your willingness to share that with your fishing partners. You can be a fisherman from a family or a community. Perplexity 22.4. 33.4 is the next one, so this should be less coherent. The key to being a successful fisher person is to learn what to eat and then follow them on. There's still plenty of meat available. Sushi is the goat. You just go with the flow. Fish are an excellent source of. So you're right. There's not much coherency here. If we go down, we find our best score of 12.05. The key to being a successful fisher person is to be careful about what you eat and what you drink. While you can fish and catch your own fish, the amount of time you spend in the sea has a huge effect on your health. So it's coherent, but it really isn't giving us what we want it to give us. So we need to calculate diversity and combine this with diversity to get a holistic view of that generated content's quality and variety. So let's take a look at diversity. There's lexical diversity, which measures the richness of the vocabulary, and syntactical diversity, which looks at the variation in sentence structure. So let's take a look at lexical diversity. So I'll paste in my code. You should already have it. Here we're running the function for lexical diversity. We hit Shift-Enter, and our lexical diversity is 0.4723. We can also do the same with syntactical diversity. So if we run syntactical diversity, this is going to examine the diversity within the text. So Shift-Enter. This one takes a little bit longer. It's going to give us our bigram and trigram diversity, and they're 0.7951 and 0.8557. So a higher lexical diversity indicates a richer vocabulary, and a higher syntactical diversity suggests more variation in sentence construction. So I hope this video showed you how to use some metrics like diversity, whether it's lexical or syntactical, and perplexities to get a more nuanced understanding of your generated content's variability. In this video, I'm going to show you how to deploy and serve generative models as endpoints in SageMaker for that real-time inference. So once you're in the AWS console, let's come up and type in SageMaker, and let's go into the SageMaker console. We're going to continue using Studio. So go ahead and click Studio on the left-hand side, and then open Studio once your user profile has been selected. If you followed along with these videos, you created the domain in a previous video, and you should have access to SageMaker Studio. Our main goal here is to deploy a model now as an endpoint. So let's come down to Jumpstart. Go ahead and select Jumpstart, and you'll see a bunch of different models that we can use. We've used Hugging Face. We've used PyTorch. All right, I'm going to deploy a Hugging Face model. So it's going to be Stable Diffusion XL 1.0. It's just an open source model. Go ahead and select it, and it tells you this model is available under the open source. It takes a textual description as input and returns a generated image from the description. So we're going to go ahead and select Deploy. It's asking me what do we want to use for an endpoint name. I can enter one, or it'll give me a default. I'm going to enter one just so I know for sure which one I am dealing with. I'm going to call it Richard Demo Endpoint. Then we choose our instance type. So I'll go with an ML G5 4 extra large, and I only want one instance. Our model is here pre-populated because we already chose it. We could add another model if we wish. Number of accelerators are going to be 1. We only want one copy of the model deployed. We have our minimum CPU, and we didn't specify a max CPU. Our inference type is going to be real time, so for sustained traffic and consistently low latency. Under advanced options, you'll see some security measures. You can select an IAM role, you can choose a VPC, or an encryption KMS key. I'm going to leave everything as it is, and I'm going to go ahead and click Deploy. And this should take a few minutes to actually deploy. You can see that it has successfully created the endpoint and added the inference component. And the status is in creating. So we're going to give that a little bit of time. Then we can take a look at what we've created. Now you can see the endpoint is in service, but the model is still being created. So we need that model to be done before we can test that inference. So now you can see that the model has been deployed, it's in service, and the endpoint is in service. So you can see the URL for the endpoint here, and that's where we can send any of our invocations. So this model is used to convert text to images, right? So we can put some text prompts to our URL through an API call or a Python SDK, and it'll turn that text into an image. Here's your URL here. Here's the ARN for Amazon use. If we come under settings, we can see all the settings that we created, the IAM role, the instance type. Here's where we can test our inference. So we can test the sample request, or we can use a Python SDK. So if we select use Python SDK, you'll see here's the code for the Python SDK, and it's going to ask for a jaguar in the Amazon rainforest. Or if we just test the sample request, we're putting in JSON and we're saying our text prompts is jaguar in the Amazon rainforest, and our width and our height. So if I actually come down and send that request, it doesn't fail instantly, it's pending. So it's creating that image for me. The only issue with this model and testing it this way is that it's too big. The image is too big to be displayed. But you can see that it does successfully generate an image. So if you were to use an API call or the Python SDK, you could see that image being created. And there's auto scaling. So if we were to set up any auto scaling, we'd see it here. Much like your EC2 auto scaling, it's the exact same thing. But this allows us to scale up and scale down our endpoints so we can host more models or we can accept more inference requests. So if we come back to models again, where it is, we can go ahead and select it. We can delete a model, or we can add another model to this endpoint. So I hope this video showed you how to deploy models to an endpoint for inference, how to potentially test these models, auto scaling, how to recognize the endpoint's URL, and to be able to use that in things like Python SDKs or just simple JSON tests. In this video, I'm going to show you how to monitor generative models in SageMaker. So we're going to monitor that training and deployment processes in SageMaker. So I'm going to use SageMaker Studio. Once you're in SageMaker Studio, Let's come down to the left-hand side and choose Jumpstart. So we want to get a model that we can train and we can deploy so we can look at the logs and metrics behind it. So I'm going to go and I'm going to choose Hugging Face again. This time I'm going to choose Stable Diffusion 2.1. And this is our text to image model. We've used this before. I want to do a train and then I want to do a deploy just so we can get those metrics and logs. So go ahead and select train. Here's all the information. You can leave it all the same. You can leave the training instance the same if you wish. So we come down. I'm going to give it a different name just so I can see it in the logs. I'm just going to call it Richard-Hugging-Face-Metrics-Logs. And that way I know exactly, because I've got a few different training jobs there. It makes it a little easier for me to identify this one. So I'm going to go ahead and click Submit. This is going to execute. We'll give it a few minutes, then we can run over and look at it in CloudWatch Logs. But there's a little delay between SageMaker and CloudWatch Logs, so we need it to execute for a little while, then we can go over and take a look. So now it's been executing for a little while. Let's go over to CloudWatch and see if we can find it. Now that I'm in the CloudWatch, let's come down to Logs and Log Groups. And now we want to find AWS SageMaker. So let's go all the way down. It's not on this page. We go to our second page. And we find AWS SageMaker. And then we want to come down to Training Jobs. So we select Training Jobs. Then we come down to Log Streams. And we see Richard-Hugging-Face-Metrics-Logs, which is the training job we just launched earlier. So if we click that log stream, we can see everything that's happening here in this training job. All right, so we can scroll down. We can see everything that gets processed, all the behind the scenes stuff from that training job itself. Right, requirements are already satisfied. It's trying to download, install stuff, uninstall things, okay? Returning some values, sets its environment variables. So if there was something going wrong, you would see it here in this log group. It allows you to see all of our inputs that we're putting in. And we can also expand each one as well. So if there's more to see, so here's our Python path. If I expand it, I can see the full Python path. We scroll down, and we can see all the steps in the training job as it progresses through. We can expand each step, see what loss may be there. And this will continue right up to 100% until it's complete. So if there are any problems, we'd see it here in the log group. We can also view metrics. So if we select all metrics, and we come back to browse, and I'm going to clear off all of what I had here previously. Let's go to AWS SageMaker Training Jobs Custom Namespaces. I'm going to go by training job name. I'm going to come down to my training job name, which is right about here, Richard-Hugging-Face-Metrics-Logs. I can select it and say search for this only. And now we can see if there are any training loss. We can graph it here. But first I'm going to come over to graph metrics and I'm going to get rid of everything. Now I'll come back and we just want to graph our training loss. And that's all we have here right now is a train dash loss of 0.14. So this is a metric that's related to the training process. And train dash loss typically refers to the training loss metric, which quantifies the difference between the predicted outputs of the model and the actual data during the training phase. Very crucial metric for understanding how well the model is learning from the training data set. So a lower loss value, which we have, 0.14, indicates the model's predictions are closer to the actual value, so better performance. Now that the training job is done, we've looked at some metrics and logs. Let's deploy it and do the same. So I come back into SageMaker Studio. Let's go ahead and deploy it. We'll leave everything the same, except for the endpoint name. I'm actually going to enter an endpoint name of Richard-endpoint. Again, just so I can see it. When I click deploy, we're going to go ahead now and create the endpoint, then deploy that model. So it doesn't take very long to create an endpoint and add the inference components, but it takes a little longer to create that model and deploy it. So let's give it a few minutes, then we'll go back over to CloudWatch and we'll check out those log groups and metrics. So it's been creating for a little while now. Let's run over to CloudWatch and see if we've got any logs generated. Back in CloudWatch, let's go to log groups. Depending on how many log groups you have, you may have to come to the second page. This time we're looking for AWS SageMaker endpoints, and then we want to find the endpoint that we just created. So now we're back into CloudWatch. Let's come down to metrics and come over to browse. I want the Richard-endpoint. So I'm going to click Richard-endpoint name, and I'm going to say search for this only. So that gives me all the metrics for the endpoint that we're creating, Richard-endpoint. So if I select them all, I can view all the metrics here. So my memory reservation is at 53.6%. My GPU memory utilization is at 36.9%. My CPU utilization, 0.27. My GPU reservation is at 100. Right, my disk utilization is at 17.4%. So these are all the metrics I can see for my deployment. So I hope this video showed you how to view CloudWatch log groups and metrics for all of your training jobs and your deployments in Amazon. In this video, I want to introduce you to the Amazon Bedrock console and the use of playgrounds in that console. So we're going to explore how this powerful platform can allow you to easily manage your AI models, run experiments, and integrate AI capabilities into your application. So once you're in the console, you can come up to the search bar and type in Bedrock, and you'll see Amazon Bedrock, and you'll be brought right into the Bedrock console. We can expand the left-hand side, and we see all of our options here. So here you'll see your overview. You can go ahead and select examples. Here's where you'll see some examples, so it's already given for you. Things like action items from a meeting transcript, advanced Q&A, chain of thought, so you can select these, and you can check all the inference configurations, all the API requests. So it's something that you can use as a jumping off point, right? Something for you to build upon. It also gives us our providers. So AI21 Labs, Amazon, Anthropic, Cohere, Meta, and Stability AI. As we select them, we can see what models they have available to us. If I come up and select Amazon, you'll see I have Titan models and all the different flavors of the Titan models. If I choose Cohere, you'll see the examples and you'll see the different models, Command, Command Lite, right? And you can open these up in the playground. You can purchase provision throughput, right? You can do everything from providers. There's also a part with their foundation models. So in the past, we've looked at foundation models. We looked at fine-tuning these foundation models, right? We looked at fine-tuning them towards a specific industry. It was no different with Amazon Bedrock. You have access to all these base models, Claude version 2, Claude Instant, version 1.3. Then we have Command, Embed. These are both by Cohere, Jurassic. So we have access to all of these base models. So we could select the base model from here. Maybe we want to take Jurassic 2 Ultra. And then we're brought back into this familiar providers screen again. Custom models. So we can create a model. We can decide the custom model that we want to create, fine-tune, or continue to pre-train. From there, we'll test that model and use a custom model. So all the models are here. We also have the opportunity to do some training jobs here. So if I come back into models again, and I want to fine-tune a model, I can select fine-tune. I can find the model that I want to fine-tune. Maybe it's Titan Text G1 Lite. I give it a name. I give it a model name. And then I give it the input data. where is the path to our data that we're going to use to train this on. And then we can set up our hyperparameters here as well. So we've previously done this via command lines, but now you can do it much easier without any API or machine learning programming knowledge using Bedrock. Now let's look at Playgrounds. So Playground is an interactive environment where you can experiment with different AI models without writing any code. So if I choose Playgrounds and I choose Chat, here's where I can play around with some of the chat models. So I go ahead and select the model. I'm going to go ahead and choose Titan Text G1 and click Apply. So now I can play around with this model. So write a prompt. What is the best color for a car? And I can run it, and now the bot is thinking, and it's going to give me a bit of information. So it says it's a matter of personal preference. However, we can provide some information on popular car colors and their meanings. We can change the temperatures or the top P. So right now our temperature is at 0, and that's a low temperature. This is going to make the model's prediction more deterministic and more conservative. At low temperatures, the model is more likely to choose the most likely next element in a sequence. This can result in more repetitive and predictable outputs, but with higher confidence in the accuracy. We can turn our temperature up, and basically temperature is just going to control that randomness of predictions by adjusting the probability distribution. If I turn it right up to 1, that means the probability distribution is unaltered and the model generates outputs based on the learned probability. This is considered a neutral setting. Anything higher than 1 will increase the randomness and diversity, and the model will give more weight to less likely outcomes. So we can change our temperature to 0.7, and we can go ahead and we can run it again and see if there's much change. And you can see there is a little change here. So there is no one best color, as it depends on personal preference. But as you can see, we're getting different text than we did before. So depending on what you want as your outcome, you can adjust the temperature, you can adjust the top P. This is also called nucleus sampling, and that's a sampling strategy used to generate sequences like text by dynamically choosing from a subset of the most probable next tokens. So we can change this top P sampling number. We can change it anywhere from 0.1 right up to 1. Our response length can also change as well. So if we want longer responses or shorter responses. So now if I ask the same thing, what's the best color for a car, but I put my responses length down to, say, 414, we should expect a lot smaller of a response. So as you can see, it's coming out, smaller response length. We can also view the model metrics here as well in the playground. We can look at the overall summary, the latency, the input token count, the output token count, and the cost. Right, so this is for chat. There's a playground also for text. So if you want to choose something like cohere command, for instance, we can do the exact same thing here. We can write prompts, enter your name, and I click run, and it gives me back, hi, my name is Corral. I'm a chatbot trained to assist human users. And again, I can change my temperature here up to, say, 4.38. Makes it a lot different. I can change my P, and I can change my K. Same thing with images as well. So you have a playground to play with all these different base models. There's also a knowledge base here that you can search, and they're Amazon Bedrock agents. So you create your agent by selecting a foundational model, add your action groups, and then deploy an agent version in your application. There's also model evaluation here as well, under assessment and deployment. And here allows us to evaluate models to see which one's going to work best for us. So I hope this video showed you how to navigate the Amazon Bedrock console, what some of the things that we can do and accomplish in the console, and how to work yourself around the playgrounds within Amazon Bedrock to find out what model works best for you and how to tune your hyperparameters without having to write any specific code. In this video, I'm going to create a custom generative AI model using Amazon Bedrock. So once you're in the console, come up to the search bar, type in Bedrock, and you'll access the Amazon Bedrock console. So in the previous video, we looked at the console, everything that we can do here. Now we want to create our own model. So we're going to create a custom model, and we're going to do that by training a base foundation model with some training data of our own. So I want to go ahead and click Custom Models. And you'll see right now we don't have any models, but we're going to go ahead and fine-tune a model. We can come up also under Customize Model, and we can create a fine-tuning job here, or we can create a continued pre-training job. I'm going to create a fine-tuning job. Same thing as if I click this button here, they'll bring you to the exact same page. And this is the page where we create our fine-tuning job. So with this video, there is a file, and it's called NHL Knowledge Dataset.jsonl, or JSON lines file. And let's take a look at it. So this file has 20 prompts and completions, all about the National Hockey League. So 20 is a very small number in the grand scheme of things, but it gives us some idea from a demo perspective what this is going to do. So it's just 20 prompts. What is NHL hockey is the prompt for everyone, and then the completion has a lot more information. So we want to train a Titan data set so that when we ask a bot what is NHL hockey, we get a bit more information than we would normally get. So we're going to train the data on this data set. So the next thing we need to do is put this data set in an S3 bucket and ensure that Bedrock has access to it. So I already have my bucket set up. My bucket is called Training Data for Bedrock. And I'm going to go ahead and I'm going to drop in my NHL Knowledge Dataset.json file and upload it. So my Bedrock has permissions to go out to S3 and grab this file and use it for training. So let's go back to Bedrock. Now we're going to select our model, and we're going to use Amazon Titan Text G1 Lite. Go ahead and click it, then click Apply. So now we have to specify the name. So I'm going to call mine NHL Train Model, and the job name is going to be NHL Train 1. And if I do any more jobs for training, I can call it NHL Train 2, 3, and so on. Next, we have to specify our input data. Ours is in S3, so click Browse S3. I'm going to sort mine by creation date. I have a lot of buckets, and I'm going to choose Training Data for Bedrock, and I'm going to select my NHL Knowledge Dataset.json lines file. Go ahead and select Choose. There's a validation dataset S3 location, which is optional. We're going to leave that optional and leave it alone. Here's our hyperparameters. So 5 epochs, that's the total number of iterations of all the training data. Batch size, learning rate, and learning rate warm-up steps. So we're going to leave all these on their default values. And now we're going to choose a place for our output data. So my output data is going to be stored at S3 Training Data for Bedrock. You can click Browse S3 and choose any bucket of your choice. Normally in a production, you may want to have a dedicated bucket for that output data because it's going to store all the model validation outputs. But for simplicity, I'll use the same bucket. Now you want to choose a method to authorize Bedrock. So if you have an existing service role, you can choose that, and you can choose your existing service role. Otherwise, click Create and use a new service role. And then we can give it a name. So Bedrock Demo Service Role, for instance. From here, I'm going to come down and I'm going to select Fine Tune Model. And now it's going to kick off the job. So the job has been created. If you click on Training Jobs, we can see it. We can see all the other jobs you may have done, whether they failed or completed. And now this is our NHL Train. So this is going to be training. This may take upwards to a half an hour or more. So just be patient, and when it's done, we can take a look at what we've created. Now we can see that it's finally completed, and if we come over and select Models, we'll see now that we have our own custom model called NHL Train Model. So now if we want to use our model, you have to purchase provision throughput. So I can select my model, I can select purchase provision throughput, I can say Richard throughput. I choose my fine-tuned model, and then I choose my model units and commitment term. So if I went with even the base model units of 1 with no commitment, you're looking at about $170 a day. If you were to go up to 10 model unit or with 1 month, you would be around $1,500 a day. So for that reason, I'm not going to actually go through with that part. I'm going to click cancel. But if we did provision that throughput, we could then go into a chat playground. We can select our model from the custom models. And from here, if we had purchased that throughput, we could apply it. And then we could use the playground to ask what is NHL. And then we would get much broader results than we would have before we actually trained our custom model. So I hope this video showed you how to take a foundation-based model, fine-tune it, create your own custom models, potentially purchase provisioned throughput, and use it for inference or use it within the chat playground to see how that training actually played out. In this video, I'm going to show you how to perform model evaluation in Amazon Bedrock. So once you're in the Bedrock console, if we come down under Assessment and Deployment, you'll see Model Evaluation. This is currently in preview mode, but let's take a look. So with Model Evaluation, you have 3 flavors here. You have Automatic Model Evaluation. So this automatically evaluates one model using the recommended metrics that you provide, and you create the evaluation. So you could look at things like accuracy, toxicity, and robustness, and your model scores are all calculated using different methods like the BERT score, F1. You can also introduce a human element, so you can bring your own work team, and that'll evaluate 2 models using a work team of your choice to provide feedback. You also can do this with an AWS managed work team. So if you want to have feedback on subjective or complex evaluation metrics, but you don't have any experts in-house to look at it, an AWS expert team will look at it for you. So we're going to create an automatic evaluation. I'm just going to call it Richard Demo Evaluation. And now we're going to select our model. So what model do we want to evaluate? So I can choose from AI 21 Labs, Amazon, Cohere, and Meta. I'm going to stick with Amazon, and I'm going to select the Titan Text G1 Lite. Now we choose our task type. So how do we want to define the model evaluation criteria? Do we want to do general text generation? So then the model will do natural language processing and text generation tasks. Text summarization. This model will summarize the text based on prompts that we provide. Question and answer, and text classification. So I want to do question and answer. And now we choose our metrics and our data sets. So what metrics do we want to use? We can choose from accuracy, toxicity, and robustness. So if I choose accuracy, I can remove it here if I don't want it. Now I choose a built-in data set. Do I want available built-in data set, or do I want to use my own prompt data set? And that's fine if you want to have your own prompt data set trained and evaluated on this model, and that way it can relate a little more to what you're trying to accomplish. For this demo, we're going to use a built-in data set, and below you can see what built-in data sets are included. So BoolQ is a question answering data set for yes or no questions. Natural Questions has real user questions issued to Google search. And Trivia QA is a reading comprehension data set. We can include all of these, or we can include just one of these. So I'll go ahead and I'll choose all 3. Then our next metric is toxicity. So this is going to gauge the propensity to generate harmful or inappropriate content. So again, I can choose a built-in data set, and I can use BoolQ, Natural Questions, and Trivia QA. And then robustness. So we're going to assess the degree to which minor semantic preserving changes impact the model's output. So we have 3 metrics. Accuracy, how well does the model output match what we expect? Toxicity, will this model generate harmful or offensive content? and robustness. And that'll assess the degree to which minor semantic changes impact the model's output. We're going to use the available built-in datasets. If we want to use our own, we just specify the S3 bucket where our dataset is. Next, our evaluation results. So what folder do we want to put our evaluation results in? I'm going to choose S3. I'm going to find the folder called Training Data for Bedrock, and the folder is Evaluation. And I'll choose that folder. If you do the same, make sure that Bedrock can access that folder and you have cross-origin resource sharing enabled. Now I'm going to come down and choose the IAM role. If I don't have a role, I can say create a new role and it'll create it for me. Or I can click cancel and choose one from previous. So if you've done this before, you'd have a previous role. Let's go ahead and create a new role for the purposes of the demo. And here is the specific models. Here's the output bucket. And now I'm going to create the role. So it takes the buckets that you passed in above and creates a new IAM role for them. So I'll create the role. It automatically assigns it. Now I'm going to create my evaluation. So if you scroll down, you see your evaluation jobs. You'll see any past jobs and their status. And you should see our job now. It's in progress. This may take a few minutes, upwards to maybe 30 minutes or more. So once it's complete, we'll take a look at what we generated. So now you can see the richer demo evaluation has been completed. You can go ahead and click on the evaluation name, and that'll bring you into our result. So you see our summary here: toxicity, robustness, and accuracy. So for question and answer types, when we look at accuracy, for this metric, the value is calculated using an F1 score. So whether we used Bool Q, natural questions, or trivia QA, the value is going to be calculated using that F1 score. And the F1 score ranges from 0 to 1, with higher values indicating better performance. So with trivia QA, we have much better performance for this model. With robustness, for this metric, the value is calculated as a percentage. So each prompt in the dataset is perturbed approximately 5 times. Then each response is sent for inference and is used to calculate the robustness scores. A lower score indicates the selected model is more robust. And then finally, toxicity. So this value is calculated using toxicity from a detoxify algorithm. So we don't need to get into the details of how that's calculated, but a low toxicity value indicates that the selected model is not producing large amounts of toxic content. So here we can see that our toxicity values are very low. So that's how we view our model evaluations. Now you'll also notice that we stored the evaluation results in S3. So if we click it, we're brought into S3 and we can look at whether it's Bool Q, natural questions, or trivia. So if I look at trivia QA, I take the output, I can go ahead and download that output, I can save it, and then I can open it. So when I open it, it looks like this. You can see the metric name, its result. All right, it's a little hard to pick out here, but it is a JSON lines file. And we can take this prompt, for example. How many points is a try worth in a game of rugby union? And then it says 5 or 5 or 5. Then it says what model invocations were used and any response text. So here the metric was toxicity. The response text was, sorry, this model is designed to avoid potentially inappropriate content. So depending on what the prompt is, it may see it as inappropriate content or not. Right, so you can view all of these, whether it's your built-in trivia QA dataset, whether it's the natural questions or the Bool Q, it's all there. So you can view that evaluation in the console. You can also view it via the datasets in the S3 bucket. In this video, I'm going to show you how to create a business application using Amazon Bedrock. So I'm going to use Amazon Bedrock and generative AI, and I'm going to implement an image generation use case. All right, so once you're in your development machine, you should have pip installed. you should have Git installed. Right, we're going to use Amazon Bedrock. We're going to create a Streamlit app, and then we're going to allow users to interact with that over the web. So the first thing we need to do is clone our repository. So let's type in git clone and the following URL, github.com/AWS RDOTY/Amazon-Bedrock-image-generation-poc.git. That should clone it. And if we do a listing, we can see it. And then let's navigate to that Amazon Bedrock folder. So now let's take a look. You can see we have app.py, imagegeneration.py, requirements.txt. So if we take a look at app.py, we can see this is our application. And this is what's going to be working with Bedrock to create those images for us. I'm going to clear my screen again. And I'm going to do a cat on requirements. This is everything that needs to be installed. It'll be done via the requirements.txt file. So I'll clear my screen again and let's get at it. So once we're inside the folder, let's type pip install virtual env. We're going to install virtual environment, and that's really good when we begin installing the requirements. So now that it's created, I'll type in Python 3.9-m venv venv. And once that returns, I'm going to go into the venv folder. Then I'm going to go into bin. Then I'm going to type source activate. And now you can see our virtual environment is activated. I'm going to come back to the root. And now our virtual environment has been created. It's been activated. We're going to install all the requirements found in the requirements.txt file. So I'm going to type pip install-r requirements.txt. So I'll hit enter. It'll take a few minutes for these to finish, but when it's all done, we should be able to fire up our application and give it a go. So it's still installing everything it needs. Once everything has been installed, you'll see what it has installed. I'm going to clear my screen. Now we want to actually run our application. So I'm going to type in Streamlit, run, and then app.py. When it runs it, it tells you exactly the IP address that you can view it in your browser. So make sure that you have the appropriate ports open. So I'm going to copy my external URL and paste it into the browser. When I navigate there in my web browser, I get this web page, image generation with Amazon Bedrock, with a prompt, ask me to create your image. So I'm going to say, draw me a picture of a hockey player scoring a goal. So when I hit enter, it begins to create my image for me. It doesn't take very long. At this point now, the application is going out to Amazon Bedrock. It's running inference on that model, and it gives me back my generated image. So this is the application. Now we can change things in the application. We can change different models. Right? This is not exactly the greatest image of a hockey player scoring a goal. So you may want to go back, fine-tune your model, change your models, whatever the case may be, to make sure that your application is doing exactly what you want it to do. So I'm going to go back into my virtual machine. So if we want to stop our application, Control-C, and I'll just clear my screen. So the last thing I want to look at is the actual image generation itself. So we see a Python file called image generation. I'm going to do a cat on image generation, and let's just take a look at what we're doing here. So we import Bodo3, JSON, bodocore.config. We import IO and base64. We configure our Bedrock client with the CLI profile name. And then we have Bedrock equals bodo3.client. We pass in our Bedrock runtime, our US East 1, and the endpoint URL. So if we come down, we have our image generator function. And it takes the user input. It calls the stability stable diffusion XL model. And from there, it sends the invocation off to Bedrock, and we get a response back, which generates our image. So again, you can use different models, you can fine tune your own models, but I hope this video was a good demonstration on how to use Amazon Bedrock with your business applications. In this video, I'm going to show you how to set up CodeWhisperer for the first time, and we're going to do that inside of Visual Studio Code. But before we do that, I want to go to the CodeWhisperer console just to take a look around and show you a few things. So I'm inside my AWS console. I'm just going to type in CodeWhisperer, and I'm going to go right to the CodeWhisperer console. So you'll notice, remember we talked about tiers? Well, there's two tiers here. There's an enterprise and an individual tier. So if I were to use an enterprise tier, I click Get Started, and you'll see that CodeWhisperer requires IAM Identity Center, which is a successor to AWS SSO. You need to activate IAM Identity Center, add users and groups, and then return to CodeWhisperer console to finish setting up. This is for the professional tier. These are for companies who are using AWS organizations. A lot of us are not. We're individual developers. So we would exit out of here, and we're going to try CodeWhisperer for free. So once you select Try it for free, we're brought into more documentation about what is CodeWhisperer, how to use it for the first time. And so now that we know which one we want to do, we're going to use the individual option, and we're going to set it up in Visual Studio Code. So let's go back into Visual Studio Code. So now I'm in Visual Studio Code. I want to come and add the AWS extension. So I'm going to come up, click my three dots, View, and Extensions. Now once we're in our extensions, I'm just going to type in AWS. Go ahead and select the AWS Toolkit. This shows you everything that we're going to install. So we're going to use Amazon Q, CodeWhisperer, Application Composer. We have options to use Amazon Code Catalyst, Explorer, and so on. So go ahead and click Install. It's going to install it for us. I'll just close this window here. It's installed for us, but now we need to actually set up our profile and log in. So let's come up top. Let's select Refresh. Then we'll come out to our additional views and select AWS. So here you'll see everything that we have available in AWS. Amazon Q, CodeWhisperer, Explorer, right? So I can open up Explorer and I can view any CloudFormation, right? So I'm logged in to Explorer using my AWS profile, which is already set up on the command line on my computer. But if we want to use CodeWhisperer, we have to sign in. So go ahead and click Sign In to get started. We want to use Amazon Q and CodeWhisperer. So if we were again using that professional tier, we'd sign in with an IAM Identity Center. We want to use for free with an AWS Builder ID. So go ahead and select it. You get a pop-up asking you to confirm this code in your browser. So KKNVGCSF. So click Proceed to Browser. I get the browser pop-up. The code does match it. It's KKNVGCSF. So I confirm and continue. Now it's asking me, do I want to allow AWS Toolkit for VS Code to access our data? As a result, it's going to enable CodeWhisperer completions. It's going to enable Amazon Q conversations in CodeWhisperer. It's going to enable Amazon CodeWhisperer analysis and get access to AWS IAM Identity Center. So go ahead and click Allow. It's granting that access. Now we can close this window and go back to AWS Toolkit. So now you can see that it says Connected, and we have options here to use CodeWhisperer. So I can close these files. I'm going to start a new Python file. You can see AWS, I have two connections here, and CodeWhisperer is currently running. So now I'm in Python. Maybe I want to create a function that's going to accept the birthday from a user. So I'll just start writing my function, define birthday user, and I'll come down and tab, and it auto completes it. Name, input your name, age, what is your age? And then it prints it out. So that's just a suggestion. If I want to accept it, I can press tab. If I don't want to accept it, in this case, I can push escape. Okay, so that's just one of the ways that you can use it to write your code. So let's go ahead and let it. I'm going to define birthday user, and I'm going to hit Alt-C here. It's going to suggest the code. I'm going to tab it and keep it. Now I can come down. I can say if, and it auto completes it for me. Name equals main, call the birthday user. So I can save it. I run it. It's asking me my name. I say Richard, my age 42. Hello Richard, you are 42 years old. I wrote that using CodeWhisperer's suggestions and completions. So as you can see, at its very basic level, it's great for helping me with productivity and knowing exactly what commands I should use. And once you get into more advanced programming, it takes it to the next level and really gives you insights on how to make sure that your code is secure and efficient. In this video, I'm going to show you how to install CodeWhisperer into a JetBrains IDE, specifically IntelliJ IDE, and we're also going to install it into a Jupyter Notebook on Amazon SageMaker. So first, let's tackle IntelliJ. So once you have IntelliJ installed, much like we did in our previous IDE with Visual Studio, we're going to come down to Plugins, and we're going to search AWS. You'll find the AWS Toolkit. Looks just like it did in Visual Studio. It has Amazon Q, CodeWhisperer. Go ahead and select Install. It's telling you that the following plugins are coming from a different source. Go ahead and click Accept. We can close this now and get a bit better of a look at what we're installing. You can see the install process here. Now it's installed. So we're going to close the IDE and restart it. So now I've restarted my IDE. I'm going to go ahead and click New Project. I'm just going to leave it as an empty project and click Create. I'll let it load that project. Now you'll notice that we have an AWS Toolkit on the left-hand side. So let me expand. I'm going to go ahead and click the AWS Toolkit. You can see it has Amazon Q and CodeWhisperer. And it's telling me to sign in to get started. So I'm going to come down. I'm going to double click on sign in to get started for CodeWhisperer. It's telling me, just like it did with VS Code, the ID is a new personal profile for builders. And you can sign up for free and get your AWS Builder ID. Let's go ahead and click Connect. Much the same as Visual Studio Code, we get an actual code. Click Proceed to Browser. Our browser will look similar to this. The code matches, so click Confirm and Continue. At this point, we're just going to allow AWS Toolkit for JetBrains to access our data. Now we're all Aaccess authenticated. We can go ahead and close the window. Now when we come back into our IDE, we can see that CodeWhisperer has an AWS Builder ID connected, and we can actually go about starting to use CodeWhisperer just like we used it in our Visual Studio Code. So now I can come over here under my project. I can right click, say New File. Just going to call it richard.py for a Python file. And I'll show you how CodeWhisperer works. I'm just going to write in this comment. Input username from user. I come down and it fills in my code for me. Right, so CodeWhisperer works just like that. So now let's take this over and let's do it within Amazon SageMaker Jupyter Notebook. So once I'm in Amazon SageMaker under Notebooks, I have my notebook created. Go ahead and click Open Jupyter Lab. And that's going to redirect us into our Jupyter Lab notebook like we've done many times. From here, we're going to go into the terminal and we're going to install CodeWhisperer. So now we have it open. We know that Python is the only programming language that CodeWhisperer supports in Jupyter Lab. So let's take a Conda Python 3. Now let's come up to File, New, and Terminal. We're going to use the terminal to install. So first thing I want to type in is pip show Jupyter Lab, just to see what version we're running. Once it comes back, it should tell us that we're running somewhere in the vicinity of version 3.6, and we are. It's 3.6.7. So the next thing we need to do is install Jupyter Lab 3. So I'm going to type in pip install Amazon-code whisper Jupyter Lab -ext tilde equals 1.0. Let's go ahead and hit enter. Should go through the install process of pulling down CodeWhisperer and installing it into our environment. Shouldn't take too long. It's a few dependencies it has to work through. So it's working its way through. It's successfully built CodeWhisperer, and it successfully installed the CodeWhisperer. So let's go ahead and clear the screen. And the next thing we need to do is actually enable the server extension. So I'm going to type Jupyter server extension enable Amazon_CodeWhisperer Jupyter Lab _ext. Go ahead and hit enter. And it said the extension has been successfully enabled. So now we can come out of our terminal, and we're going to actually refresh this page. So I'm going to hit F5, and that should refresh our notebook, and we should have access to CodeWhisperer now within Jupyter Notebooks. So when it refreshes, you do get a little message here. It says CodeWhisperer isn't enabled. If you exit out, we know it's not true because CodeWhisperer is right here with the check mark. You can see all your shortcuts, you can pause the suggestions, and so on. So CodeWhisperer is working perfectly inside Jupyter Labs. So I hope this video showed you how to install CodeWhisperer into a JetBrains IDE and how to install CodeWhisperer into Jupyter Lab. In this video, I'm going to show you how to perform security scans with CodeWhisperer in Visual Studio Code. So with this video, you have a zip file of a code project with a lot of security issues. So let's extract that file. Once you have it extracted, let's come up to File in your IDE, whether you're in Visual Studio Code, JetBrains, and we want to open a folder. We're going to go to that folder where we stored it, and I'm going to open it. So it's called bad. I'll select that folder, and then it opens it up in Explorer. It asks me if I trust the authors. In this case, I'm going to say yes. And now we have our project here. We're going to perform our security scans on. So you'll see all of our Python files here. All right, what this does is irrelevant right now. We just want to run a security scan. So I'm going to open up one of my pages. Doesn't matter which one. And I'm going to extend out to AWS. I'll click AWS. Now we see CodeWhisperer. Here's where we want to run our security scan. So go ahead and click Run Security Scan. Now it's scanning the active file and all the dependencies in that file. So once it comes back, it'll give us a full list of all our issues, and it happened really quick. So the security scan completed for 18 files, so all the files in that directory, and 47 issues were found. So go ahead and click Show Scan Files. It's going to show you all the files that it scanned, which are files in the directory. And if you click Problems, it shows you the file and the problem located with that file, what line it's on, and so on. You could just click it, and it brings you right to it. So you'll notice in API post.py, on line 27, column 1, we have a file injection. This is a security vulnerability where an attacker can inject a file or content into a web application. and then that'll be executed or processed by the server. And we know that that can lead to a wide range of security issues, data breaches, execution of malicious code, and so on. When you click it, it opens the file for you and it highlights the issue. We come down, this file also has a resource leak. So a resource leak occurs when a program doesn't release the resources that it acquired. So resources in this context usually refer to system resources because system resources are finite and they must be managed by the application, right? So if it opens, it needs to close it as well. Coming down, we can see an OS command injection in brute.py. It even highlights it for you. And if you hover over it, it gives you more information on it. So it tells you that it is high priority and that passing user-provided input to Python subprocesses without validation makes your code vulnerable to running arbitrary operating system commands. And then it tells you how to prevent it and a little bit more information on it. So if you click any of these, CWE-77, it just brings you into, once you trust it, the common weakness enumeration website. And that's going to show you all your common weaknesses and how to remediate them. So coming back into CodeWhisperer and coming down through a little bit, you can see there's a SQL injection in db.init. And when we hover over it, it is again of high priority. And they even give you some recommended changes to mitigate these issues. I can come down, I can see I've got insecure cryptography. So you can see that I'm running, and this is critical, right? I'm running an insecure cryptography. So to make the code more secure, I should use secrets. If we scroll down, we can see we've got some more resource leaks. We got improper error handling, don't pass generic exception rule. And again, all these hard-coded credentials, right? If I click it, you can see it's a hard-coded and it is of high priority. Right? So anything up in high, critical, these are serious issues that need to be remediated. If you scroll down, you see we've got more cross-site request forgery, enabling and overriding the debug figures, and so on. Then we even have things like importing Flask could not be resolved, inefficient string concatenation. So not only security, but it actually tries to improve your code as well. So it's a full comprehensive suite. One last thing, if you double-click it and copy, you can actually import it into a JSON file. So this is what it looks like once you copy it. It gives you the resource, owner, the severity, the message, how was it detected, so the source, start line number, column, end line number, and end column. So you can take all these JSON files, you can put them into some code repository, or you can put them in some ticketing management system just to make sure that all this get rectified before you release your program. So I hope this video showed you some of the benefits of using the CodeWhisperer security scan. In this video, I want to expose you to Amazon Polly and how to use the text-to-speech converter in the console. So once you're in the AWS console, we can type in Polly in the search bar, and let's go into the Amazon Polly console. So once we're here, it's very simple. You have three options here. You have text-to-speech, lexicons, and S3 synthesis tasks. So let's take a look at text-to-speech. So the first thing you'll notice is that you can choose from three different engines. Neural, which produces more natural and human-like speech. Longform, which produces the most natural-sounding speech. And Standard, which just produces natural-sounding speech. You can choose your language. So we have multiple languages from Arabic to Cantonese, all the way down to German, Hindi, Turkish. And for each language, we also have different voices. So I can choose English US, and I can have Sally as a female. So when I click listen,
Hi, my name is Sally. I will read any text you type here.
You can see that it actually plays it. So now I can, again, change voices. I can use a male voice, And this just gives you the option to scroll through these voices and see which one you'd like to use.
Hello, my name is Kevin. I will read any text you type here.
So you can see that's more of a young male voice. Right? So once I choose a voice, maybe I want to use English Australian. And I want just a female voice because that's all that's available there under the neural. Click listen.
Hi there, my name is Olivia. I will read any text you type here.
You can get your English Australian female. If I go into long form, you'll notice that Olivia female isn't supported by this engine. Right? So this is the most natural sounding speech, but is not available for every language. You can see, in fact, it's only available for English US. And in English US, there's only a specific number of voices that you can use. Danielle, Ruth, and Gregory. So if I run Gregory,
Hey, I am Gregory. Test my voice on longer content such as news articles, training materials, or marketing videos.
so if I copy this and come back to neural, we can just compare it. So quick listen again.
Hey, I am Gregory. Test my voice on longer content such as news articles, training materials, or marketing videos.
Sounds a bit robotic, right? But long form,
Hey, I am Gregory. Test my voice on longer content such as news articles, training materials, or marketing videos.
you have those nuances, right, that you'd expect. So long form is going to produce the most natural sounding. And then, of course, standard. Standard, I can choose Matthew.
Hi, I'm Matthew. I will read any text you type here.
Very robotic, like the older days. All right, so neural or long form. It's going to give you your best sounding speech. So we've discussed the different engines, the different languages, and the voice. We can also come down and expand on additional settings. So here we can change our speech file format settings. So we change our sample rate, or our file format can be MP3, speech marks, OGG, and PCM. And we can also use the SSML markup language here as well. So you'll see speak and the content and then speak. So if you want to write your own SSML, you can do it right here in this box. I'm going to turn it off because I want to show you about lexicons. So if we scroll down, you'll see customized pronunciation. So go ahead and select it. Here's where we can create lexicons. So lexicons are used to define phonetic pronunciations of words. So I'm from a province in Canada called Newfoundland, but a lot of times it's pronounced Newfoundland, or a lot of different other pronunciations. So if I type in Newfoundland and I click listen,
Newfoundland.
I get Newfoundland. Right? It should be Newfoundland. So I'm going to create a custom lexicon. So I have my custom lexicon here right now, and the XML lexicon defines the pronunciation of Newfoundland using IPA symbols. So the new represents the stressed new sound. Here we have the fun part, and land indicates a secondary stress on land, and that's using the phonetic pronunciations, right? So keep in mind that exact phonetic representations can vary, right? And it's sometimes a trial and error to get this correct. So you have this file that came with your video. Save it. Let's come down. Let's upload the lexicon. I'm going to choose the lexicon file, which is nl.xml. And I'm going to give it a name. I'm just going to say Newfoundland and click upload. So now we have to apply the lexicon. But first, I'm going to turn it off just so we can remember what it did sound like.
Newfoundland.
Now I turn on my custom pronunciation and I choose the one I just picked, Newfoundland, and I run it again.
Newfoundland.
And now you hear the land. It's not a big difference, but it's enough of a difference that you can interpret it. So if we try it in a different voice, let me try it with Kimberly. I'll turn off the custom pronunciation.
Newfoundland.
And I'll turn on the custom pronunciation. And I'll make sure Newfoundland is chosen.
Newfoundland.
So it sounds a little better. All right, you can manage all your lexicons over here. I can delete, download, and here we have synthesis tasks. So here you'd see all your speeches that you saved to S3 buckets. And if you want to create a new task, you could do that here. So I hope this video showed you the ins and outs of the text-to-speech feature in Amazon Polly that you can use with the console. So go ahead, play around, find the right speech for you, and create some lexicons to really get the most out of Amazon Polly. In this video, I'm going to show you Amazon Polly in the console, as well as using Amazon Polly on the AWS CLI. So in our last video, we went over Amazon Polly in the console itself. We talked about the different engines that you can use, different languages, different voice. We even took a look at speech file format settings and lexicons. We can also save to S3. So it's one important thing we didn't really discuss on, but if I want to take this voice.
Hi. My name is Joanna. I will read any text you type here.
I can save that to S3 by specifying my bucket. Or I can download, and it'll download as an MP3 file format. I can also use SSML here as well if I wanted to use SSML directly into my input text. The next part is the command line. So we can perform almost all the same operations on the console and the CLI. However, we can't listen to synthesized speech on the CLI. So in order to work with audio on the CLI, we have to save our text to a file, then open the file in an application that can play it. So let's go ahead and let's open up our command prompt. You should already have the AWS CLI installed. So if you type in AWS, I see usage for AWS. So I know I have the command line installed. If it said AWS command not found, then you know you have to install the command line. So let's go ahead and type in AWS Polly help. And you can see that I get a description back and a list of different valid commands. So Amazon Polly is available in my CLI, and we can use it immediately. So I'll go ahead and expand my command prompt, and we can take a look at some of the available commands. So we can delete lexicons, we can describe voices, we can get lexicons, list lexicons, start speech synthesis task, synthesize speech. So we can see we have 10 available commands here. So let's go ahead and start using it. There is code that came with this video that we can paste in. I want to actually type it in so we can kind of understand what we're doing at each line. So I'm going to clear my screen. So I want to type in AWS Polly synthesize-speech. So this is the synthesize speech command. My output format is going to be MP3. My voice ID is going to be Joanna. And I have to specify my text. So in this case, we just want to say, hello, have a great day. And then we're going to call it hello.mp3. But I have to save it on my hard drive. So I'm just going to say c:/cbrh/hello.mp3. Go ahead and hit enter. It's doing something in the background. And then we see our output. So it sends the output to the console. Told me my content type was audio, MPEG, and the request characters was 23. So we can go ahead and try and find that file right now. And it's exactly where I saved it, CBRH. And when I run it,
Hello, have a great day.
you can hear that it plays, and it's playing in my Windows Media Player.
Hello, have a great day.
So in addition to that, we can also do an AWS Polly describe voices. We can take a look at all the voices and it gives you their gender, the ID, the language code, and what supported engines there are. Right, so I can come down. Maybe I want to use Astrid this time. So I just keep hitting space until we get through all the voices. I'm going to clear my screen, and I'm going to run the previous command, but this time I'm going to run it with Astrid. And I'm just going to call the file hello2. Hit enter. We get our output again. Let's check out the actual outputted file. So I play hello2.
Hello, have a great day.
And now you get Astrid. So as you can see, it's pretty easy to use Polly within the command line as it is within the console. So I hope this video can get you started and you can go in and start exploring and using Polly in your application. In this video, I'm going to show you how to use Amazon Polly API calls within a Windows application. So you'll see that right now I have a Python application in my JetBrains IDE in Microsoft Windows. We want to simulate making API calls out and then integrating that with Windows Media Player so we can hear it after we make that API call. So we're going to demonstrate how to use Python with COM, or the Component Object Model, to interact with Windows SAPI alongside Bodo 3, the Amazon Web Services SDK for Python to interact with Amazon Polly for text-to-speech capabilities. So we all have Python installed on our system. You will need to install the Bodo 3 package by running pip install Bodo 3. From there, we're going to reference our script that came with this video. So the first thing we need to do is initialize the Bodo 3 client for Polly. And then we're going to send a text to Amazon Polly, save the audio stream, and then use the Windows SAPI to play the saved audio file. So once you load this script into your IDE of your choosing, as long as you have Python and Bodo installed, you can run it. So the first thing we have is our import statements. So we're importing Bodo 3, which imports the Bodo 3 library, which is the AWS SDK for Python. Then from Bodo core.exceptions, we're importing Bodo core error and client error. That imports exception classes from Bodo core. From context lib, we're importing closing to ensure proper cleanup of resources in our file stream since we're dealing with files in Windows. And we're going to import OS, sys, and subprocess. And that's going to import those modules for interacting with the operating system. So the next thing we need to do is initialize a Bodo 3 client for Polly. So we create a variable called Polly client. Then we say Bodo3.client Polly, and that creates a client object for interacting with the Amazon Polly service. And this client provides methods that correspond to API operations that we can call. Next, we have our text-to-speech request. So the script tries to call the synthesized speech method. So there's a few different actions with the Amazon Polly API, such as delete lexicon, describe voices, get lexicon, put lexicon, synthesize speech, and that's the one that we're using right now. So we have the try block, we have our response, we're calling the Polly client, and we're passing in the synthesized speech API. Then we have our text, so this is what we want to hear. This is what we want converted to speech. Our output format is MP3, and our voice ID is Joanna. So Joanna is one of the available voices. We could change that if we wish. Then we need to handle the response. So if the synthesized speech call is successful, the response object should contain an audio stream. And it should have, with closing, response audio stream as stream, and that's going to ensure that the stream is properly closed after accessing its content. Then the script tries to open a file for writing the output, and then if it can't, we want it to exit gracefully. And in our else block, If the response didn't contain any audio, want you to print out that it could not stream any audio, and then again exit gracefully. Then we're going to play the audio using the default audio player. And if the audio file is not found, we want to print that out to the user as well. So let's go ahead and run it. I'm going to click play on my file.
Hello, this is a demo of Amazon Polly.
And now you can see that it does indeed go up, convert the text to speech using the synthesized speech API call, and then it opens it up in Windows. So we can change this. We can say, congratulations on finishing this demo. We can run it.
Congratulations on finishing this demo.
So I hope this video showed you how to use Amazon Polly with API calls to synthesize speech from text. So each request to Amazon Polly to convert text to speech, like the one we made in the Python script using the synthesized speech method, counts as an API call. So again, get in, look at the different actions and different API calls that you can make with Amazon Polly, and then start putting it to use in your Windows environment with your Windows application. In this video, I'm going to show you the difference between using plain text and SSML within the Amazon Polly API. So you'll remember from our last video, we just did a normal text input. So we imported Bodo 3. We called the Bodo 3 client for Polly. And then we called the synthesized speech API. We passed in text. We just passed in plain text. Congratulations on finishing this demo, with an output format of MP3 and the voice ID of Joanna. From there, we saved it and we played it. So when we run it,
Congratulations on finishing this demo.
we get our output called speech, just as we asked for. So how does that different from using SSML, or speech synthesis markup language? Well, SSML enhances the naturalness of the synthesized speech because you can control aspects like pauses, emphasis, pronunciation, and you could even bring in some fun things like whispered speech or increased pitch. So let's take a look at that. This was our text. Now let's come over to SSML. So you also have this script with this video. So load that in and let's take a little look at how it differs between text and SSML. So you'll notice here everything else is exactly the same code-wise, but you'll notice the two differences here. Our text actually has SSML tags within it, and our text type is SSML. So this time, you'll notice SSML has a speak tag and has everything you want to talk about within those speak tags. So we've got an opening speak tag and a closing speak tag. The first thing we're going to ask for was, tell us a joke, but I want to bring in a break time tag. So between asking the question and revealing the punchline, I want a bit of a break there. And I also want to turn up the volume a little bit. So you'll see I have Prosody volume plus 1200 decibels. And of course I have the Prosody tag to close it all up. So when I play it, let's go ahead and run it.
Why was the computer cold? Because it left its windows open.
So as you can see, I left a reasonably long space in between, so we could change that break time. It was 10,000 milliseconds. Let's change it down to 1,000 milliseconds. I save it. I run it again.
Why was the computer cold? Because it left its windows open.
Much faster. So you can play with things like break time. You can play with the Prosody volume. In addition to this, we can also specify how to say certain words. using the say as element. So let's change this out now, and let's type in today is, and now we're going to start our say as tag. Say as interpret as equals date. So we're telling it to interpret this next text item as a date. And the format is month day. We close it off, then we'll put in the date. So March 6th. And then we need to close off our say as tag again. So now when I go ahead and then push run,
Today is March 6th.
it interprets 3/6 as March 6th. So that provides some additional context because we have that interpret as attribute. I want you to interpret that 3/6 as a date. And finally, the last thing is we can use it to improve the pronunciation of foreign words. So Polly's going to assume that the input text is in the same language as the language spoken by the voice we chose. So we chose Kevin, English voice. It's going to assume that that input text is also going to be English. Sometimes we need to tell Polly to apply different pronunciation rules. So let's erase everything between our speak tags, and let's type in that restaurant is terrific. And now we're going to add a language tag. So lang XML :lang equals es-es Espanol. And I'm just going to type in mucho gusto. And I'm going to close off my lang tag again. So now when I play it,
That restaurant is terrific. Mucho gusto.
and now because the language is English for the input, Polly's going to map the Spanish phonemes to the closest English ones. As a result, Kevin speaks the text as a native US speaker who pronounces the word correctly in Spanish, but with his US English accent. So I hope this video showed you how to incorporate SSML into Amazon Polly. So go in and look at the different things you can do. We looked at a few things. We looked at volume. We looked at pausing. We looked at languages and interpret as. But you can do things like emphasis, whispering, right? So go in, take a look at what's available to you, and apply it to your Amazon Polly implementation. In this video, I'm going to show you how to log API calls to Amazon Polly with CloudTrail and how to integrate that with CloudWatch and CloudWatch Metrics. So once you're in the Amazon console, let's come up and let's just type in CloudTrail. And let's go into the CloudTrail console. So from here, we want to create a new trail. So let's come on the left-hand side and let's click Trails and let's click Create Trail. Now we're going to give it a name. So I'm just going to call it Richard-Trail. I'm going to let it create a new S3 bucket. I'm going to have log file SSE KMS encryption. I want it to create a new customer managed key. I'm just going to call it CT-key. Log file validation is enabled. I come down. I want to enable CloudWatch logs. So I want to configure logs to monitor our trail logs and notify us when something happens. So I'm going to create a new log group. I'm going to call it AWS Richard Log Group Polly Trail. I'm going to let it create a new IAM role for me. I just have to give it a trail name. I'm going to call it Polly-Richard. And I'm going to click Next. So now it's asking me what events. Do I want management events, data events, or insight events? So I want to capture management operations performed on our AWS resources. And I want to see all the API calls that are going to Amazon Polly. I could also choose data events as well if I want to log any resource operations performed on say our databases and stuff. I'm just going to leave it on management events, read and write. Go ahead and click next. Everything looks good. I'm going to go ahead and click create trail. Now this trail might take a couple minutes for it to actually start bringing in data. So while it's doing that, I'm actually going to go in and select the trail. And now I'm going to go back and make some API calls. So I'm in my original Python file that we created. I'm just going to run this a couple times
Congratulations on finishing this demo.
just to get some API calls in. Okay, so I did that a few times off camera, and that should hopefully get us some data in the CloudTrail and into CloudWatch as well. So you can see our trails here, our CloudWatch logs are here as well. So if I want to stop logging, I could stop it, so on. So now come to the left-hand side and let's select Event History. And this is where we can look up our event history. So we want to look up by event name. And our event name is Synthesize Speech. So if I go ahead and select Synthesize Speech, right now you can see the CloudTrail event history for synthesizing speech. So with CloudTrail, I can select one and I see the whole event record. I see the IAM user, the ARN, the account ID, even my access key, my username, shows the event time, the response elements, what the event type was, so it was an AWS API call. It is a management event, and it shows us the client provided host header, the source IP address, the region, and so on. What the source was, it was poly.amazonaws.com. So CloudTrail will keep track of all this. Reason being is that if it gets abused or if there's things going on that we need to see and we need to react to, all this information will be very important to us. So on the flip side, we also have CloudWatch. So let's come over to CloudWatch. And here we can look at metrics and we can look at those logs. So once we're in CloudWatch, let's come over to all metrics. Let's come down. You should see Poly now. So go ahead and select Poly, select Operation Metrics. You can see all these metrics. I want to see synthesized speech. So I want to see the response latency, the 5xx count, the request characters, the 2xx count, and the 4xx count. I'm going to come up. My time is the last 3 hours. And I'm going to use a number. So I can see the average response latency is 47.2 milliseconds. Request characters 41.2. I've had one 2xx count and no 4xx and 5xx. We also have CloudWatch logs. So if we come up under logs and we look at log groups, once it loads the log groups, we should find the log group that we just created, which mine was AWS Richard Log Group Poly Trail. And now we have some log streams here. So if we select one, you can see who invoked it, right? So basically we're taking that CloudTrail and we're putting it into a log event for us. From here, I can take these log events, I could tie it in to EventBridge, and I can force some different actions based upon whatever's happening here in this log group. So what this log group really does is it serves as a container that's going to store and organize logs generated by Poly and other AWS services. So that gives us that centralized logging, that monitoring and alerting, even audit and compliance and operational insights. So I hope this video showed you the importance of using AWS CloudTrail and CloudWatch log groups and metrics to get insights on your Amazon Poly API usage. In this video, I want to show you a little bit more about the available voices and languages that you can use in Amazon Poly. So we'll look in the console And then we'll also look at some of the documentation. So let's go ahead and once you're in the Poly console, go ahead and click Try Poly. And then we're brought into the Amazon Poly console. So we understand the engine. We've been through the engine. You have your neural, your long form, which is the most natural sounding, and then standard. But let's take a look at the different languages that we can avail of. So we have Arabic, Cantonese, Catalan, Chinese, Danish, Dutch, and a bunch of different English, various dialects. So you have Australian, British, Indian, Irish. So if I say English, Indian, you can see the voice switches right over to Kajal. Now you go ahead and click listen. If I change it over to Irish, then it changes the voice. And I click
Hi.
listen.
My name is Neve. I will read any text you type here.
That's English Irish. So not every voice is available with every dialect, right? English Irish only has one voice. If I come back to English Indian, it has one female voice in neural. If I go to long form, you'll notice that Kajal isn't supported, neither is Aditi or Ravina. Standard will let me use Ravina and Aditi. So if I click listen.
Hi, my name is Aditi. I can read any text you type here.
So you can see, depending on the language, depending on the voice, you may have to use different engines. I can go ahead now, I can go to English US. You'll notice we have a lot of different voices available for us. We can use Kimberly.
Hi, my name is Kimberly. I will read any text you type here.
Again, very robotic. If we try long form, Kimberly's not supported. You would have to use Ruth.
Hey, I am Ruth. Test my voice on longer content, such as news articles, training materials, or marketing videos.
Or standard will allow me to try Joanna, Kendra.
Hi, my name is Kendra. I will read any text you type here.
There's also SSML markup language here, so we can adjust our SSML like we just did in the previous video. And if we come down under speech file format, we can adjust our sample rate and the file format. Another couple things I wanted to discuss would be just some of the documentation on voices in Amazon Poly and using SSML in Amazon Poly. So in the developer guide for Amazon Poly, you'll see voices in Amazon Poly. This gives you a good quick overview on what language coincides what name and gender, and are they available in neural, standard, or long form. So if I know that I need a Japanese language, I can come down to try and find Japanese. Now I know I have 4 different options available, 3 female, 1 male. They're all available in neural voice except for Mizuki. And Mizuki and Takumi are available in the standard voice, and none of them are available in long form voice. So if I need a long form voice, it's another easy way to find out what voices I have available. I can just look here and I can scroll up until I see a yes. And then I know that Ruth, female, is available long form voice for English US. And if I keep scrolling up, you'll see Gregory and Danielle are as well. You can also see what voices are bilingual with a single asterisk. So Hala, Zayed are bilingual. If they have the double asterisks, they can be used as newscaster speaking styles. And your triple stars are your long form and NTTS voices. So it's a good little chart to become acquainted to see what you can use. The next thing I want to look at is the supported SSML tags. So you got to look at the action you want. So we have different actions here, adding a pause, emphasizing a word, all the way to controlling volume, controlling how special types of words are spoken, speaking softly. So these are your SSML tags. And here it tells you the availability with neural voices, So adding a pause has full availability with neural and long-form voices. You can't emphasize words with neural voices or long-form voices. And things like controlling volume, speaking rate, and pitch, you have partial availability with neural voices and partial availability with long-form voices. So these are two very important tables to see what languages you can use and what languages are supported and what SSML tags are supported in the specific engines. So I hope this video gave you some insight on the languages that are supported, what voices are bilingual, what voices are available on what engine. In this video, I'm going to show you a feature called speech marks. And speech marks allow developers to receive metadata about the synthesized speech. And these speech marks are intended for use in applications where precise synchronization between the audio output and the visual elements, like text highlighting or lip sync animation, is needed. And there are several types of speech marks available. Let's take a look. So once we're in Amazon Polly, we can go ahead and click Try Polly. And now you'll notice I have English language and my voice is Gregory Male. It doesn't really matter what you choose here, but we want to come down and under speech file format settings, if yours is unticked, go ahead and tick it. And our file format will be speech marks. You'll notice there's 4 different types of speech marks: sentence, SSML, Viseme, and Word. Let's take a look at sentence first. So I'll select sentence. I'll come up and I'll click download. And I'm just going to call this sentence so I can look at it and know which one is which. So let's pull up the sentence. So these files can open in Notepad. And the sentence speech marks provide information about the start and end times of sentences in the synthesized speech. We can use it to highlight text at the sentence level as the corresponding speech is played back, and that can improve accessibility and engagement in applications like e-learning platforms or audiobook readers. So you can see the time is 0 seconds, the type is a sentence, starts at 7, ends at 25. Here is the value of the sentence, and same for the next sentence. So if there were 100 sentences, you'd have 100 entries here. Now let's check out what the word speech mark does. So come back to your text to speech, come down, and under speech mark type, untick sentence, and let's do word. Go back up, click download. I'm going to append this one with word. And once it finishes downloading, you should be able to open it. And here you can see word. So these give the timing information for each word that's spoken in the synthesized speech. A very granular approach, and it allows for much more precise synchronization, such as highlighting individual words as they're spoken. This is very useful for language learning applications, read-along features in ebooks, or any applications that benefit from word-level synchronization. Much more granular than sentence-level synchronization. Now let's go back and let's see what Viseme speech marks are all about. So let's exit out of Word, select Viseme, come back up and download. Again, I'll just suffix. And once it downloads, we can take a look at it. And here we have it. So these offer information about mouth shapes that correspond to the phonemes or units of sound being spoken. These are essential for animation. So if you want to animate characters or avatars and you want to achieve realistic lip syncing, this is how you do it. By knowing when and which Visemes to display, developers can create more lifelike and engaging animations for virtual assistants, animated characters in games, or educational software. So it shows you the time and the value. So you can really use this to map it to your characters. And finally, the last option would be SSML. So if we were using SSML tags, then we can use the SSML speech marks to indicate where specific SSML tags occurred in the synthesized speech. And that's used to adjust and control aspects of speech synthesis like pronunciation, volume, pitch, rate, and pauses. And these SSML tag speech marks can help in debugging SSML documents by giving you some insight into how the speech synthesis process interprets the SSML tags. So I hope this video showed you the different types of speech marks that you can avail of and how to go about getting them. In this video, I want to show you some of the API actions that you can utilize within your application. So mostly so far we've been focusing on one API action, and that's synthesized speech, right? That's what we've been using to convert our text into speech synchronously and then retrieve the audio stream. But I want to show you a few more because there are 9 in total. So we have delete lexicon, which is going to remove a lexicon. Describe voices, lists all the available voices in Poly. Get lexicon, retrieves information about a lexicon. Get speech synthesis task will check the status of a previously started asynchronous synthesis task. List lexicons is going to list all of our lexicons. List speech synthesis task is going to retrieve a list of all those tasks. Put lexicon uploads a new lexicon. Start speech synthesis task, and of course synthesize speech. So I've got a script here. You have it too. It's included with this video, and it utilizes all these different API actions. All right, so first thing we do is initialize a Poly client using the Bodo 3. I'm using Python, but if you're using something else, these API actions, no matter how you implement them, they are still going to do the same thing. So the first one we have is put lexicon, and that's to upload a custom pronunciation lexicon. So we give it a name. We call it demo lexicon. Then we have our XML content right inside of our Python code. Right? It gives it the XML-NS, the instance, the alphabet, and the language, and it passes in a grapheme and a phenome. From here, we call the put lexicon API call. So we say poly.putLexicon. We pass in the lexicon name and the content that we provided above. And then once it's finished, the lexicon is uploaded. Next, we do a list lexicons. So this will list all the stored lexicons. So we just create a variable lexicons. Then we bring in poly.listLexicons. That stores it into our table. And then we actually print out the name of all the lexicons that we have stored in our account. Then we can get a lexicon. So if we want to retrieve a newly uploaded lexicon, we just say poly.get_lexicon, and we pass in the lexicon name. So let's take a look at, let's just run these. So I'm going to just cut out the rest of this just for a second, and we're going to run the code and see what it looks like. So we're using our put lexicon, our list lexicons, and our get lexicons. So when I run it, you can see it uploads the lexicon, it gets the list of all the lexicons, and then it pulls down and gets the last lexicon that we created. So now I'm going to paste that code right back in, and we'll look at the next ones. So we have describe voices, poly.describe_voices, and that's going to pull back all the different voices that we have available to us. Synthesized speech. We've been using synthesized speech in this course. This is what actually turns the text into voice content. Here we're just saving the audio stream to a file. Here we have a start speech synthesis task. So this is going to start a task to synthesize speech to S3. So this will be good for scenarios where you need to synthesize a large amount of text into speech, or if you prefer to process audio synthesis asynchronously. So that'll allow your applications to continue running without waiting for the speech to actually synthesize. It's great for back-end processing and batch operations. We have list speech synthesis tasks, so that'll give us a list of all the tasks that are currently running. And get speech synthesis tasks will get the status of the previously started task. And finally, delete lexicon will allow us to delete our lexicon. So if I run it all. Now we have our output. So we have our lexicon uploaded. So we know that that is our put lexicon API call. List lexicon API call is next. Then we have the get lexicon API call right here. Then we have our describe voices API call. So all the available voices are here. We have our synthesized speech here, and we saved it to an MP3 file. Our speech synthesized task that we started. So when we started the start speech synthesized task API, it started it. Then we went about to list it, and then that was running. And then we wanted to get a task status, so we used the get speech synthesis task API. And finally, we did a delete lexicon API call to delete the specified lexicon. So I hope this video showed you how to use all the available API calls that you can use within Amazon Polly. In this video, I'm going to show you how to get started with Amazon Lex, and we'll create a very simple bot from an example in the console. So once you're in the AWS console, let's come up to the search bar. You can type in Lex and you'll see Amazon Lex. Go ahead and select it. And now this is the Amazon Lex console. So on the left, you'll see bots. So any bots that we created, bot templates. There's also a network of bots. And then we have test workbench. So we can create test sets, we can view test results, and we have some related resources like documentation. We want to create a bot from an example just to get some hands-on usage with Amazon Lex version 2 console. So once we're here, let's go ahead and select bots, and we're going to create a bot, and we're just going to use an example this time. So go ahead and click create bot. You can see we have 4 creation methods. Descriptive bot builder using generative AI. We can create a blank bot, or we can start with an example, or we can start with transcript. I want to start with an example. It's just a pre-configured languages, intents, everything already filled in, just so we can take a look at what we're going to create when we create a custom bot. So under example bots, I'm going to use order flowers. And now you'll come down and you'll see all the bot information. So the languages that are supported. If we come down, we can give it a name. So we can call it order flowers demo. I come down, I'm going to let it create a role with basic Amazon Lex permissions. And is the bot going to be used in the Children's Online Privacy Protection Act? So if it were to be used by children, we would say yes. In this case, we're going to go with no. We also have things like idle session timeout. So how long before we have no interaction are we going to time out and close the chat? This one says 5 minutes. We can leave it as it is. Again, we'll customize all this stuff when we create our own. Go ahead and click next. Now you can see it's telling me what language do I want to add. I'm going to use English. And what voice. So I can use Danielle, Gregory, right? All those voices we looked at in Amazon Polly. I'm going to play the example to see how it sounds.
Hello, my name is Danielle. Let me know how I can assist you.
Not bad, kind of robotic. If we were to take Gregory.
Hello, my name is Gregory. Let me know how I can assist you.
Seems a little more smooth. I'm going to choose Gregory in this case. So I'll click done. We could add another language if we wanted to. And now we have our chatbot. So at this point now, we can build it or we can test it. We have our conversation flow here. We have our intent details, right? We're intending to order a bouquet of flowers. Sample utterances. I would like to pick up flowers. I would like to order some flowers. So these are phrases we expect the user to speak. We can change this as well. And we have our initial responses. Okay, I can help you with that. And then we have things called slots. So slots are information that a bot needs to fulfill its intent. So if there's a prompt for flower type, then we have a slot type for flower types. Pickup date, then we have a slot type which is dynamic called Amazon.date, and pickup time. So we're going to go ahead and build this bot. We know it'll work. It's an example from Amazon. It should work. Now it's going to build the bot, and when we're done, we can test it to see what the conversation looks like by starting with one of the sample utterances. I would like to pick up flowers. So give it a few minutes for it to build, and then we can give it a test. Now you can see it's been successfully built. Go ahead and click test, and now we can start to test it. So I'm going to say, I would like to buy flowers. What type of flowers would you like to order? Tried and true, roses. What day do you want the roses to be picked up? Now, if I just put in gibberish like so, it repeats it again. What day do you want the roses to be picked up? Because it didn't pick out Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, or Sunday. So if I say Sunday, at what time? I'm going to say 4. But it doesn't know if it's 4 p.m. or 4 a.m. You see? So if I say 4 p.m., okay, your roses will be ready for pickup at 4 p.m. on March 17th. Does this sound okay? Yes. And now the intent order flowers is fulfilled. Normally we wouldn't put that in to a production, but we're just testing it. So this is the long and short of how to create a bot. And it's just an example overview, right? When we build our own, we'll actually customize some of the intents and slots and utterances. So I hope this video showed you just how to get into Amazon Lex and familiarize yourself with the Lex version 2 console. In this video, I'm going to show you how to build a bot from scratch using prompts, intents, and slots. So once we're in the Amazon Lex console, let's go ahead and click Create Bot. And this time we're going to create a blank bot. So go ahead and select Create a Blank Bot. And we're going to give it a name. So I'm going to call it Online Coffee Order. And the description's just going to be simple bot for kiosk to take coffee order at small family run business. Something very simple. You can create a role with basic Amazon Lex permissions, so it'll create it for you. Is our bot subject to Children's Online Privacy Protection Act? It is not, in this case, going to be used by kids in that manner. Go ahead and click Next. It's going to ask us what language we want. We can choose from any of these. I'll randomly choose Joanna.
Hello, my name is Joanna. Let me know how I can assist you.
And I'll click Done. Now it's going to create our first intent for us. So I want to create the first intent to be get coffee. And it's just going to be a way to order coffee through the bot. So we'll come down and we need utterances. So what are phrases that we're going to expect the user to say? Things like, I need coffee. May I have a coffee? Can I order a coffee? Coffee. And coffee, please. From here, we can have our initial response. So I can say, okay, sure, we have coffee. And here's where we have slot. So this is information that the bot's going to need from us. So go ahead and click Add Slot. We're going to have name. So we'll say fname, and that slot is going to be Amazon first name. And we'll just say, what is your first name? And we'll click Add. And we're also going to add a slot for coffee type. And this slot type will just be an Amazon free-form input. And what would you like? And we can go ahead and add that slot. So we have 2 slots here. Now we have confirmation. So this will help clarify whether the user wants to fulfill the intent or not. So if we want prompts to confirm, can I go ahead with your order? Or decline. So if they say no, okay, is there anything else I can help you with? Now we have fulfillment. So if they say yes above, then we're going to fulfill it. So we're just going to put in a message. Okay, I have sent your, and now it's going to be coffee type, to the barista. Thank you. And it should say their first name. In case of failure, oops, sorry, we are all out of, and then we type in our coffee type again. And for our closing response, we could say, thank you for ordering. Please proceed to the counter. I can go ahead now and click Save Intent. It saves our intent. And now we can actually add another intent. So we go back to intents again, add another intent, and this one's going to be order food. Just to show you how we can have multiple intents here. So this is going to be order snacks from the front counter. Our utterances, I want a snack. Do you have any food? We can keep it simple. Our initial response, absolutely, let me help. And then we can add our slot again. So we'll just ask for first name. What is your name? And we'll add a slot for food type. And that'll be Amazon.freeform input. What would you like to eat? We click Add. Then for confirmation, can I proceed? And for fulfillment, we'll just say, thank you, and pass in the name. Your food type is being prepared. And for a closing response, we'll say, thank you for ordering. So we'll go ahead and click Save Intent. It saves our intent. Now we want to build and test it. So go ahead and click Build, and it'll start building our bot. And again, this is simple, but you could integrate Lambda functions. You can make this more dynamic. You could have Lex go out to Lambda and see what coffee types are available, see what quantities are available. So you can make it a lot more complex as well. But just to show you the ins and outs here, we'll keep it a little bit simple. So once it's built, we can actually go about testing it. So it's been successfully built. Go ahead and select Test and say, can I have a coffee? Okay, sure, we have coffee. What is your first name? Let's see, Richard. What would you like? I'll have a latte. Can I go ahead with your order? Yes. Okay, I have sent your latte to the barista. Thank you, Richard. Thank you for ordering. Please proceed to the counter. Can I have a snack? Absolutely. Let me help. What is your name? Richard. What would you like to eat? Fruit bar. Can I proceed? Yes. Thank you, Richard. Your fruit bar is being prepared. Thank you for ordering. And then we're done. Right, so it's a very simple example, but it shows you how we can implement different intents and different slots in your Amazon Lex chatbot. So get in, play around with Amazon Lex, and create some bots that you know can help you in your day-to-day life or with your software application. In this video, I want to demonstrate a little bit more about deployments and aliases. So once we're in the Amazon Lex console, let's go ahead and click Create Bot. We're going to create a very simple bot. In fact, we're going to start with an example, and we're going to choose the Book Trip bot. We'll come down, we'll call the name Book Trip Demo, and we're going to use an existing role. If you don't have one that looks like AWS Service Role for Lex v2, you can also create a role. Click No for the bot being subject to COPPA, and click Next. I'm going to leave everything else the same. I'll click Done, and then we'll just take a quick look at the bot that was deployed for us. So they created an intent called Book Hotel. We have sample utterances. We have slots. So what city we'll be staying in, check-in dates, nights, room types. We have confirmation prompts. So go ahead and save the intent. And then once it's saved, we're going to build it. So right now it's not built any changes. Go ahead and build the chatbot. This is going to take a couple minutes. And once it's built, I'll show you how to create a version and then an alias from that version. Because the first version you'll notice is called draft, right? And that draft version is just that. It's used for testing, it's used for development. We're not actually going to point an alias to it. In order to point an alias that we can use in production, we need to create a version. And that's what we're going to do now once this gets built. So now you can see it's been successfully built. We can test it. Just to be sure, I need a hotel. What city? New York. What day? April 4. How many nights? 3. Okay, so we know that it works, and that's fine. So at this point now, we've built it. Let's come back out to Amazon Lex again, and let's go into bots. And let's take a look at our Book Trip Demo bot. So you'll notice here, if we go ahead and click Bot Versions, there's one version, and that's the draft version. So let's go ahead and let's say we want to promote this to production. I'm going to create a version, and I'm just going to come down and click Create, and this will create version 1. We're also going to create an alias. So let's come down to the left-hand side for alias, and I'm going to create 2 aliases here. I'm going to click Create Alias. I'm going to call it Dev. And I'm going to choose an existing version. So I'm going to choose my Dev to be version 1. Version 1 is the version we're working on. This is the development version. So if anyone calls something to that development alias, it's going to go to version 1. So I click Create. And now we have a Dev alias that's associated with version 1. We have a TestBot alias that's associated with the draft version. But hypothetically, during development, we noticed something that was wrong in version 1. So we're going to go back into our bot under Book Trip Demo. We're going to come down to our intents. And the book, the hotel, we want to edit that. So I'm going to select it. I'm going to come down. And for a slot, I'm just going to make it very simple. I'm going to say what room type. Would you like Queen, King, or Deluxe? It's now going to be Queen, Deluxe, or Honeymoon Suite. Just a really simple change. And once I'm happy with that, I'm going to save the intent. And of course, I'm going to build the changes. So once this one gets changed now, we'll create a version 2. Create a production alias and point it to that newly created version. So just give it a second and it'll be built. So now we know the draft version has been changed. Let's come back under bots. Book trip demo. Let's come under bot versions again. And we're going to create another version. And we're going to say we updated room types. I'll click create. Now I want to come into aliases. I'm going to create a new alias called prod. And I'm going to point that to version 2 and click create. So now under prod, we have an ID. Remember we used IDs in the last video when we integrated Poly. I could integrate certain channels. So if I wanted to add, say, Facebook or Slack, I could do that on this version, but not the other version. Okay. And if we were to come back into our versions again, say bot version, and let's say version 2, we can come in, we can make a change, or we could delete it, right? And it's not going to affect version 1. Or we can create another version. We can go into production, and then we can update what version this points to. So if we click edit, we can say, all right, I want this to be on version 1 or version 3. So we can have multiple versions, we can have multiple aliases, and then we can point the aliases to the different versions as we want. That's great for development. That's great for testing or blue-green testing, right? So in the same way that we use Lambda functions with aliases, we can do the exact same thing with Amazon Lex with the concept of aliases, versions, and deployments. In this video, I'm going to show you how to integrate the bot we just created with Amazon Poly so we can integrate that voice chat with our Lex bots. So with this video, you have files. There's a Python file, which is what we're going to use as our program. Plus, there's also a zip file. It's very important that you unzip the contents of that zip file under FFFmpeg. You want to make sure under bin that these 3 exe files are in the same folder as the .py file. And that's very important to get this to work. Otherwise, very simple. First thing we're going to do is come into Amazon Lex, and under bots, let's go ahead and select our online coffee order bot. Now, as of right now, we only have an alias. So let's come into bot versions. Once you're into bot versions, let's go ahead and click create version. Right now we have a draft version, but we want an actual version number. So let's click create version. Everything else can stay the same, and we're just going to click create. And that should give us, it'll give you version 1, gave me version 2. I did some testing before the video. So once we have a version, let's come down to aliases, and I want you to click create alias, and let's call this prod, P-R-O-D in all capital letters, and choose an existing version. So we want to associate a version with this alias, so we're going to say version 2. You can see it's successfully built and it's enabled. Go ahead and click create. So now it's time to mark down a few values. So under online coffee order for bot details, I want you to record the bot ID. Under aliases, select prod and mark down the prod alias ID. Now open up the IDE of your choosing, and let's look at that Python file. So here's the Python file. You'll notice that we're importing PyDub. So there's a couple more modules that you will have to install. I've previously done that, but if you just install pip install PyDub, pip install PyAudio, and pip install FFmpeg. Once these are installed and you have those .exe files under the same folder as your Python file, we should have no problems. We should be ready to go. So let's look at the code itself. Obviously, we're importing Bodo 3. That's our Python SDK. And then from PyDob, we're importing audio segment and we're importing play. We're also importing input-output. So our first piece of code is to initialize our clients for Lex v2 and Poly. So we have Lex client equals Bodo3.client and our Lex v2 runtime, and our Poly client equals Bodo3.client Poly. Next, we have a function called getLexResponse. These are where your values that we recorded earlier will be inputted. So I'm going to update my values now. So my bot ID should be BHYST, and that it is the same, but my bot alias ID should be different. So my alias ID, I have to update, and you're going to have to do the same. So we have the bot ID, we have the bot alias ID, our locale is English US, and your session ID is whoever you're going to run this as. The text is going to be the user input. Our next piece of code is to concatenate all the messages. It's no good for the bot just to read the first message. We want it to read the whole conversation. So we create a messages where we do a get on the content, and then we concatenate them up. So that's our getLexResponse function. Now we need a function for text-to-speech. So we initiate our Poly client. We say we want text. The output format is going to be MP3, and the voice ID is going to be Joanne. Then we're going to use an in-memory bytes buffer to avoid writing data to the disk. So we create an audio stream, we call response, and we read it into our buffer. Then we have a simple function called playAudio that brings in the audio. And then we have our main function. So it's going to ask for the user input. Then we get the Lex response by calling getLexResponse. We can print the Lex response. I have it commented out, but we can uncomment it if we wish. Then we have our audio variable, which calls the text-to-speech function and passes in the response. Right, so we get the response, we take that response, pass it into the text-to-speech function, we play the audio, and then we call main again so that we can capture the whole conversation. So let's come up, and I'm going to run my file. I get my user prompt, so I'm going to say, coffee please.
Okay, sure, we have coffee. What is your first name?
So the chatbot, we can see the chat that we created in the last video. Now we're getting the voice. So I'll say Richard.
What would you like?
I'm going to say a latte.
Can I go ahead with your order?
Sure.
Okay, I have sent your latte to the barista. Thank you, Richard. Thank you for ordering. Please proceed to counter.
And just like that, we've integrated our Lex chatbot with Amazon Poly. So again, get in and take that chatbot that you may have created for your own organization or your application, and then enhance it even more with Amazon Poly for text-to-speech. In this video, I'm going to show you how to integrate Amazon Kendra with Amazon Lex. So in this video, there's a few files that are attached. We have two CSV files, which we're going to use in Amazon Kendra. We also have two zip files, one for our bot and one for our Lambda function. So you want to make sure you have those files ready before we begin to create our Amazon Kendra index. So chatbots are great because they can answer a lot of canned questions, but if we can integrate it with Amazon Kendra, our bots can go out to Kendra and get answers for us. So that typically will make our bot even more powerful. So the first thing we need to do is come up to S3, and we're going to create a bucket in S3 that's going to hold our FAQs. So go ahead and click Create Bucket. I'm going to call it Richard FAQ-709, just something unique. I'm going to come down, I'm going to turn on public access for the time being and enable versioning. And I'll go ahead and click Create Bucket. So once your bucket is created, you can go into the bucket and we're going to upload our 2 CSV files. So go ahead and click Upload. Let's add the files. Let's find the files. So workdocs-FAQ CSV and helpdesk FAQ CSV. Go ahead and open them and click Upload, and they'll upload. Let's take a quick look at what's in those files. So when I open up these CSV files, you'll see the workdocs FAQs. It's just questions like, can I use Amazon Workdocs mobile apps to access, store, and sync content? And for helpdesk FAQ, we have things like, where is the help desk? What time does the help desk open? So by taking these CSV files, indexing them in Kendra, our chatbot can now use them. So go ahead and click Close. The next thing we want to do is come over to Lambda. So let's type up Lambda in the search bar. And we're going to go ahead and now we're going to click Create Function. So I'm going to create a function. I'm going to call it Richard _ helpdesk _ helper. It's going to be in Python 3.12. And go ahead and click Create Function. Once the function creates, we'll import the Lambda zip file that we have with these videos. Let's come down to Upload From. Click Zip File. Click Upload, and let's find the helpdesk bot lambda handler.zip file. And go ahead and click Save. So once that's completed, now we have our Lambda function. We have our S3 buckets. Now we need to go into Amazon Kendra and make our index. So now let's come over to Kendra. So let's type Kendra in the search bar. And we're going to create an index. So go ahead and click Create Index. I'm going to call it Lex Richard Demo. You can call yours what you wish. We're going to come down. We're going to create a new role. And we're going to give it a name. We can call it Kendra Demo. Right, so you get the prefix. You just put in what you want as a suffix. Click Next. We're not going to use any tokens for access control or user group expansion. Click Next again. And we're going to go with Developer Edition. Click Next. And click Create. And that's going to create our index. And then we're going to go in. And then we're going to tell it where to go get those CSV files that we want to integrate. So let's give it a minute to create this index. So you can see it's still creating the following index. It can take up to 30 minutes, but it won't take that long for this demo. So now you can see it's been successfully created. Let's come down and click FAQs on data management. And we're going to add an FAQ. So we're going to call this one Work FAQ. The FAQ file format is CSV. And we're going to go and browse that S3 bucket we just created to find those FAQ files. So once I get through all my list of buckets, I should be able to find the bucket that I want to use, Richard FAQ 709. So I'll select it, and I'm going to select the workdocs FAQ.csv. So go ahead and click Choose, and come down to create a new IAM role. Again, it's going to create the prefix. You just put in your suffix. So I'll just say Richard. Now we'll come down, we'll click Add. That'll add that FAQ for us. And then we'll do the next FAQ. At that point, then all we have to do is upload our bot and test out the integration. So let's give this a minute here. Now you can see that it is active. Let's go and add another FAQ. I'm just going to call it help-desk FAQ. Again, the file format is CSV. We find the file in S3. And we select the helpdesk FAQ. So go ahead and click Choose. We can create a new role. We can use the last role that we just created, which will be a little quicker. Go ahead and click Add. And now it's creating the helpdesk FAQ. So we have both of our FAQs inside Amazon Kendra. So our next thing we need to do is deploy the sample bot. So let's come up under Lex, and let's go into the Lex console, And we're going to return to the version 1 console for this demo. So go to the version 1 console. Under Actions, click Import. Under Upload File, click Browse, and you want to find helpdeskbot.zip. So go ahead, click Import. It'll import that bot. I already had this created, so it's asking me, do I want to overwrite? I am going to overwrite. For you, it'll be just a simple import. So now we have our bot. If we click our bot, we see all of our intents here. We're going to create a new intent. So click the plus icon, and we're going to search for existing intents. And under built-in intents, select Kendra Search Intent. We're going to give it a name, _helpdesk _Kendra Search, and click Add. Now we come under Amazon Kendra Query that we created. We're going to choose the index that we created. We're going to let it add the Amazon Kendra permissions. And we'll leave fulfillment to return parameters to client. Under response, we do need to type in a different response. So go ahead and click Add Message and type in this response. So it looks like this. _, x-amz-lex, Kendra -search -response -question _answer -answer -1 and our 2 closing brackets. So let's go ahead and click Save Intent and build. So we'll let it build, and then once it builds, we'll test it to see if it is actually integrating with Amazon Kendra. So you can see it was built successfully. Let's go ahead and interact with it and test our bot. So first thing I want to type in just to test this bot is going to be help desk related. So I can type in, where is the IT help desk? And when I type in, where's the IT help desk, you know it's taking it from Kendra because the intent here says help desk Kendra search. So it's using Kendra to go out into that CSV file and get the answer to my question. If I say, can I come in at noon? Sure, what's the problem? I have a cracked laptop screen. And then it asks me for my last 4 digits. So as you can see, we can make our bots a little bit more powerful by integrating Amazon Kendra and being able to pull responses from indexes that are stored in Amazon S3. In this video, I want to show you how you can enhance your chatbots with the concept of responses. So once you're in Amazon Lex, go ahead and click Bots. And let's take a look at the online coffee order bot that we created in a previous video. And we can just enhance this a little bit and look at different types of responses. So go ahead and click it. And now responses are the final element of a bot's intent. And they're displayed to users after a fulfillment is complete. So a response could be anything from a hello to a goodbye, okay? Or it could be different types of coffee that they have available that they can order. So response consists of messages, and they're dynamically selected from a group of predefined messages. And those predefined messages are created by us. So once we're here, let's go ahead and click the draft version. And we're going to make some edits to this draft version. So go ahead and click Intents, and go ahead and click Get Coffee. So here's where we can make some changes. So our intent here is to get coffee. We have utterances like I need coffee, may I have coffee, can I order coffee? And here's where our responses are. So we have our initial response. Okay, so I can have, okay, sure, we have coffee. But if I click variations, I can have absolutely, what can I help you with? Or coffee is what we do best. So it's not the same static response every time you come on to the bot. You'll get something a little different, a little dynamic. So then we come down, we have our slots, but then we have our confirmation. So prompts to confirm the intent. Can I go ahead with your order, or is there any decline response? That's fine. We can click advanced options, and then we have more options here like a confirmation response. So when the user confirms an intent, the bot's going to say, great, I'll proceed. Or I can have, again, different variations. I could say on it, or we are making it right now. We also have a decline response. So if the user declines the intent, is there anything else I can help you with? Or we can have variations in our responses like, so sorry, we could not help you today. Okay? Then we have different response options here that we can put in should we want to. So if we click add, we can add card groups, we can add SSML languages, and so on. So we can make it a lot more dynamic. In this case, I'm just going to cancel. I'm going to leave these responses and message groups, and I'm going to click update options. And for closing, so we have some closing responses as well. Thank you for ordering. Please proceed to the counter. We can also have, again, different variations. Thank you. Hope to see you again. And then we can save our intent. Now, before we test this draft version, I'm going to click build and let it build. Once it's built, then we can test it and just double check to make sure that it's invoking the different responses dynamically. So now if I type in, can I have a coffee? It says, absolutely, what can I help you with? If I refresh and type in, can I have a coffee? Again, absolutely, what can I help you with? I refresh, can I have a coffee? Coffee is what we do best. So you're getting that dynamic responses, right? You're getting something a little different each time. Richard, what would I like? I'm going to say a latte. Can I go ahead with your order? Yes. On it. Right? So that was one of the variations of responses that we created when we created a fulfillment response. Okay, I've sent your latte to the barista. Thank you. Thank you, and hope to see you again soon. So I hope this video showed you how you can add some dynamic responses to make your chatbot flow a little smoother and make your chatbot a little less robotic by having a little bit different of a conversation flow each time you go about using it. In this video, I'm going to show you how to integrate your chatbot with a web UI. We're going to do this with the CloudFormation script that's included with this video. So once you're in the console, let's type in CloudFormation and let's go to the CloudFormation console. And here we're going to create a stack. So if you've never used CloudFormation, basically it's called infrastructure as code. We have a YAML file with this video that has all of our code, and it's going to create all of our resources from that code. So go ahead and click Create Stack and select with New Resources. The template is ready, and we're going to select Upload a Template File, choose File, and then let's find the YAML file, and now go ahead and click Next. From here, we need to provide a stack name. And I'm going to use the online coffee order bot that we created earlier. So we have to go back to Amazon Lex at this point, and we're going to have to specify our bot ID and our bot alias ID. So let's go back to Amazon Lex, and let's find that information that we're going to have to take note of. So here's our online coffee order ID. I'm going to go ahead, I'm going to copy the ID for the bot and save it. And I also want to come down to aliases, and I want to find the alias for version 2, and I'm going to copy that one as well. So we're going to go back now into our CloudFormation and fill in those parameters. So I'm going to fill in my bot ID, and I'm also going to fill in my bot alias ID. We'll come down, we'll leave everything the same. It's going to create a Cognito user pool, but all this can stay the same. But you'll notice the web app configure initial text This is set up for flower ordering. So this script, if we don't specify our own bot, it'll use the flower ordering sample bot. So we're just going to change this. We're going to change it to something like, you can ask me for help ordering coffee. And just type coffee or click on the mic and say it. And that should be fine. And after the initial speech, say coffee to get started instead of flowers. And we can leave everything else the same, but you'll also notice that there's a web app config toolbar title called Order Flowers. We're going to call this Order Coffee, and then we can leave everything else the same, and then we'll click Next. We'll leave everything else the same here as well. Click Next. This is just to review what we've created. We're going to click our checkboxes to acknowledge that we're going to create some resources, and then we'll click Submit. Now this is going to take 5 to 10 minutes to create. And when it does, we can look at what it created, and we can do a demo of the web UI. So now you can see that everything is complete. We created our main stack and all of our nested stack. So let's take a look at what it created. So come over on your main stack, and let's click Output. So it created a code pipeline to deploy. We have a web app, a domain name that goes to a CloudFront distribution. We have S3 static websites. So if we look into our nested application stacks, you'll see a bunch of different resources. Cognito user pools. So let's click on the outputs of our main stack, and we'll see the web app URL. Go ahead and click it, and that should load our coffee chatbot. So you can see now, once it loads, you see the order coffee, and then you can ask for help ordering coffee or just type coffee.
Say coffee to get started.
Coffee, please. And then it listens, processes.
Okay, sure, we have coffee. What is your first name?
Richard.
What would you like?
A latte.
Can I go ahead with your order?
Yes, absolutely.
Okay, I have sent your latte to the barista. Thank you, Richard. Thank you for ordering. Please proceed to counter.
So once it's all complete, I can click thumbs up or thumbs down to end. So I hope this video showed you the capabilities of integrating Amazon Lex with a web UI and being able to have users speak to your chatbot using their voice. In this video, I want to give you some exposure to some of the AWS services that you can use to deploy your generic AI applications. First one being SageMaker. So if we come up under the search bar and we type in SageMaker, we'll go into the SageMaker service. Here's where we can train and deploy our services. And it's important that we have a robust and scalable solution so that we can grow and our AI applications can grow and we can scale up and we can scale down as necessary. I like using SageMaker Studio. And once you get into SageMaker Studio, it's a very easy to use interface and it kind of walks you through everything. So you have all your applications here, Jupyter Lab, RStudio, Canvas. We can come down, we can look at jobs. Here's where we can create some training jobs. And as you can see, I have training jobs here. So once I'm here at my training jobs, I can select a training job and I can come up and deploy. So if I click deploy, here's where we kind of get to see that scalability and that robustness in action. So I can choose my instance type, multiple different instance types to choose from. How many do I want initially? What's the minimum number of copies? What's the number of accelerators? What's the minimum CPU? We could also specify a max CPU if we wish. This will allow us to be able to scale. I could start initially with 10, or I could start with 1. If we come down to advanced options and expand advanced options, you'll see the ability to put it into a VPC or to use an encryption with KMS. So I could go ahead and deploy here. So not only can we scale for training jobs, we can also do things like use EC2 spot instances, which can help reduce our cost. All right, we can scale when we do inference because SageMaker supports automatic scaling for inference endpoints. There's also a feature called elastic inference, and that allows us to attach the right amount of GPU-powered inference to our endpoint. That allows us to scale the GPU resources separately from the CPU resources. And we can also have batch transform. So for use cases that we don't need real-time inference, we can take advantage of SageMaker's batch transform as well. That allow us to process our data files in a batch. Therefore, it'll scale compute resources to accommodate that size. So I'll come down if everything looks fine, and it does. I'm going to click deploy. And then once it deploys, we can take a look at the deployment, and we can take a look at a little bit more of the fine-tuning of our scaling. Now we can see that our model is in service. If we come under deployments and select endpoints, and we go ahead and click our endpoint, we can go ahead now and select auto scaling. You'll see the model name. Go ahead and select. Then you can select edit auto scaling. So here's where we have our scale in cooldown period and our scale out cooldown period. So scale out is the process of adding more instances to a deployment, and scale in means removing these instances. So in the context of SageMaker, we want to automatically launch additional instances when the traffic to an endpoint exceeds our configured threshold. We also want to scale in when the load decreases, so we optimize our costs without any sacrifice in performance. So SageMaker is going to monitor the traffic and automatically scale when the traffic drops below a certain threshold for a configured duration. So our scale out and scale down periods are crucial in this scaling process because they're designed to prevent rapid fluctuation in the number of instances. So the scale out cooldown method is a period which we have set to 600 seconds where SageMaker doesn't initiate another scale out activity. This period allows the newly launched instances to start handling traffic, making sure that we don't scale out again immediately before the effects of the previous scale out are actually observed. Scale in, very similar to the scale out. This period is when we have a scale in activity. We want to not initiate another scale in activity. So we set this to 600 seconds as well. That keeps us from scaling in too quickly and ensuring that the system stability is maintained. So we have left these to 600 seconds. Our instance count range is 1 to 20, meaning our minimum of 1 to a maximum of 20, and our target metric is invocations per copy. So once you get 50 invocations per copy, it's going to scale out. Once it drops back down below 50, it'll scale back in. So we can go ahead and change any of these values if we wish. We can leave it as it is for now. Click cancel. And that's the ins and outs of scaling and being able to be elastic when it comes to generative AI and SageMaker Studio. Now let's talk about deployment on AWS for your generative AI applications. So AWS provides a scalable and highly available architecture that supports a wide range of applications, from simple websites to complex AI-driven solutions. The architecture is designed to ensure that the applications remain resilient, responsive, and cost-effective. So with capabilities like elasticity, high availability, and a global network, you should have a scalable and highly available architecture and infrastructure available to you. AWS provides a wide array of foundational models and services for building AI and machine learning applications, and it has a cost-effective infrastructure. Its pricing model is based on consumption, meaning that you pay only for the resources that you use. So what tools can we use for building generative AI applications in AWS? We know we can use Bedrock, a fully managed service that gives you access to large language models, and it's a straightforward way for developers to integrate advanced natural language processing into their applications without needing to train models from scratch. SageMaker is a comprehensive service that covers the entire machine learning lifecycle, so it allows you to build, train, and deploy your machine learning models at scale. And one of the things we haven't discussed yet was Amazon EC2 Ultra Clusters. And that represents the pinnacle of AWS's computing resources, designed to handle the most demanding machine learning workloads. These ultra clusters provide vast amounts of computing power by leveraging the capabilities of AWS's P4D instances, which are equipped with the NVIDIA A100 Tensor Core GPUs. So the Amazon EC2 INF2 instances are optimized for generative AI. They're tailored for machine learning inference, making them suitable for generative AI applications that require on-the-fly predictions, such as natural language processing, image generation, and speech synthesis. They leverage the AWS Inferentia chips, which provide machine learning inference acceleration. This provides you with high performance and a low cost. These instances are engineered to deliver high throughput and low latency for inference workloads, and they provide a cost-effective solution for machine learning inference by offering this high performance at lower costs compared to instances that aren't specialized for inference. And given the variable demand for inference workloads, these instances can easily scale, providing flexibility in maintaining performance without incurring unnecessary costs. Amazon EC2 INF2 instances are inference optimized instances in EC2. So they come with the AWS Inferentia chips that are optimized for machine learning workloads. They're scale-out inference supported by Neuron Link. So it leverages the AWS Neuron SDK to efficiently run inference at scale. And Neuron is specifically designed to support Inferentia chips and help in parallelizing inference over multiple chips. So we can use multiple chips and run in parallel. And that allows us to do large-scale inference. There's also efficient deployment of large models. These instances can efficiently deploy large generative AI models that may not fit into the memory of a single GPU, so it partitions them across multiple chips. This helps reduce the overhead by managing large-scale inference deployments, simplifying the deployment and management of generative AI models. These Amazon EC2 INF2 instances offer up to 2.3 petaflops of deep learning performance, which is critical for your applications that require intensive computation. And these would be your generative AI tasks, things like real-time language translation or image generation. With 384 gigabytes of accelerator memory, these instances can handle large models or serve a larger batch of smaller models in parallel, reducing latency and increasing your throughput. And it provides 9.8 terabytes per second of bandwidth, which ensures rapid data movement within the instance. And this high bandwidth is particularly advantageous when dealing with large models that require the movement of a significant amount of data in and out of the accelerator memory. Amazon CodeWhisperer can also help you accelerate your development. It's a programming companion that accelerates your development by providing real-time code recommendations. It's trained on billions of lines of code, enabling you to generate code snippets and complete functions that align with the context and intent of your project. This service integrates with your development environment, enhancing productivity and maintaining coding best practices for security. Now let's discuss some pre-trained AWS AI services, starting with computer vision services. So Amazon Recognition, Amazon Lookout, and AWS Panorama are all part of AWS's suite of computer vision services. Recognition offers image and video analysis, including facial recognition and object detection. Amazon Lookout for Vision focuses on using machine learning to identify defects and anomalies in industrial products. And AWS Panorama enables the application of computer vision to analyze video feeds in real time, suitable for tasks like monitoring workplace safety and optimizing retail operations. AWS also has automated data extraction and analysis services. Amazon TextStract is a service that automatically extracts text and data from scanned documents, including forms and tables, without the need for manual effort or custom code. Amazon Comprehend is a natural language processing service that uses machine learning to uncover insights and relationships in text. It can analyze sentiment, extract key phrases, identify entities, and classify text. And Amazon Augmented AI, or A2I, facilitates the easy integration of human review into machine learning workflows. This service allows developers to build applications that require human review of machine learning predictions, such as content moderation or text extraction verifications, ensuring that the outcomes meet the desired level of accuracy. We have language AI services like Amazon Lex, builds conversational interfaces into any application using voice and text. It powers the Alexa virtual assistant and provides deep learning functionalities of automatic speech recognition and natural language understanding. Amazon Transcribe is an automatic speech recognition service that makes it easy for developers to add speech-to-text capability to their applications, supporting various audio formats and recognizing multiple speakers in the audio. And Amazon Polly is a text-to-speech service that turns text into lifelike speech, allowing developers to create applications that talk and build entirely new categories of speech-enabled products. Customer service improvement services. So Amazon Kendra is an intelligent search service powered by machine learning designed to enable organizations to provide more relevant information to customers and employees when they need it. Kendra understands the context of natural language queries to return more accurate results. Amazon Personalize allows developers to create individualized recommendations for customers using the same machine learning technology used by Amazon.com. It's designed to improve user engagement by delivering personalized experiences across various applications and platforms. And Amazon Translate is a neural machine translation service that delivers fast, high-quality, and affordable language translation. It supports translating text to and from multiple languages and is suitable for real-time and batch processing tasks, helping to break down language barriers for businesses globally. Business metric services. So Amazon Forecast is a fully managed service that uses machine learning to generate highly accurate forecasts for time series data. It's designed for applications such as demand forecasting, inventory planning, and energy demand forecasting. Amazon Fraud Detector leverages machine learning and more than 20 years of fraud detection expertise to identify potentially fraudulent activities in real time, such as online payment and identity fraud. And Amazon Lookout for Metrics. This uses machine learning to automatically detect and diagnose anomalies in business and operational data, such as sudden dips in sales revenue or customer engagement, without requiring any machine learning expertise to set up and manage. There's code and DevOps services. So Amazon DevOps Guru is a machine learning powered service that provides intelligent recommendations to improve application availability and reduce operational issues. Amazon Code Guru Reviewer is an automated code review service that helps developers improve their code quality by identifying potential defects and issues, such as resource leaks, potential concurrency race conditions, and deviations from best practices. And Amazon Code Guru Profiler helps developers optimize their applications by identifying runtime performance issues and providing recommendations on how to fix them, thereby improving application performance and reducing operational costs. We have industrial AI services like Amazon Lookout for Equipment that uses machine learning to analyze sensor data from industrial equipment, and Amazon Monitron is an end-to-end system that uses sensors and machine learning to monitor equipment and detect abnormal conditions, such as an increased vibration or a temperature spike. And of course, we have healthcare services. So AWS HealthLake is a HIPAA-eligible service designed to store, transform, and analyze health data in the cloud. It offers healthcare and life sciences organizations the ability to ingest and store data in a secure, compliant, and scalable environment. And we have Amazon Comprehend Medical. So this is much like Amazon Comprehend, but it's used to extract relevant medical information from unstructured text. So it can identify medical conditions, medications, dosages, and more. So it'll help the healthcare providers understand and organize medical documents, which should improve patient care and reduce manual data entry. Discussing security, compliance, and vulnerability management in the context of cloud computing requires an understanding of the complex and dynamic nature of cloud environments. Trust plays a foundational role in cloud computing, as it's essential for fostering relationships between cloud service providers and their clients. This trust is built on the assurance that the cloud service providers can deliver secure, compliant, and resilient services. Enriched vulnerability management at the application level is particularly important because applications are increasingly becoming the primary target for cyber attacks. This form of management includes scanning and assessment tools, patch management, security information and event management, and DevSecOps integration. So incorporating artificial intelligence into security, compliance, and vulnerability management introduces innovative approaches to handling unstructured data, enhancing detection capabilities, and creating more adaptive security measures. AI's potential to transform these areas lies in its ability to analyze vast amounts of unstructured data, learn from security incidents, and predict future threats with a level of speed and accuracy unattainable by human analysts alone. A critical aspect of implementing AI in these domains is understanding the relationship between input data and output. So this relationship is complex, especially with unstructured data, which lacks a predefined data model, and therefore requires more sophisticated processing and interpretation by AI algorithms. The quality and relevance of the input data directly influences the accuracy and reliability of AI outputs. Vulnerability management is a critical aspect of organizational cybersecurity strategy and is designed to prevent unauthorized access and protect against potential threats. This systematic approach involves several key stages, the first being identify. So this involves using various tools and techniques to scan systems, ensuring that we are up to date with our patch management and our applications are protected against known vulnerabilities. These tools can range from network scanners, which inspect ports and services, to application-specific scanners that look for vulnerabilities in web applications. Once vulnerabilities are identified, they need to be classified or prioritized based on the level of risk they pose to the organization. Remediation involves taking action to fix the vulnerabilities identified and classified as posing significant risk. Remediation can take a lot of different forms depending on the nature of the vulnerability and the affected systems. It often involves applying patches or updates provided by vendors to fix known vulnerabilities in software and hardware. Mitigation refers to the process of reducing the impact of vulnerabilities that cannot be immediately remediated. This could involve implementing additional security controls, changing configurations, or even segregating networks. Mitigation is particularly important for vulnerabilities for which no patch is available. So when it comes to identifying, classifying, remediating, and mitigating, the integration of AI and machine learning does introduce additional attack vectors, such as adversarial AI attacks, where attackers manipulate the input data to AI and machine learning systems in order to trick them into making incorrect predictions or classifications. So protecting against these threats requires a robust security posture that implements data best practices, that includes the protection of training data, continuous monitoring of AI and machine learning systems, and the implementation of robust data validation and filtering processes. The use of AI and machine learning in vulnerability management exemplifies the broader challenge of balancing security with innovation. So while these tools can provide significant advantages in detecting and responding to threats, these technologies also require careful management to mitigate the risks that they introduce. So organizations must implement best practices for data management, model training, and system monitoring. Now there's three critical components of a machine learning system. First, input attack vector. So this refers to the manipulation of the input data provided to a machine learning system. So attackers may inject malicious data to influence the training process or to trick the model into making incorrect predictions. The machine learning model itself can also be an attack vector. So here, attackers might seek to understand the model's structure, its parameters, or the learning algorithm to identify weaknesses that they can exploit. And the output attack vector. So this vector concerns the manipulation of the outputs of a machine learning model. So an attacker might have access to the interface of a machine learning system and be able to repeatedly query it to receive predictions. By carefully analyzing these predictions, the attacker might be able to derive confidential information about the model or the data that it was trained on. Amazon Bedrock is a service designed for building and scaling generative AI applications. It provides users with access to a variety of high-performing foundation models for both text and image generation through a single API, which includes models from notable AI companies like AI-21 Labs, Anthropic, Cohere, Meta, and Stability AI. One of the key features of Bedrock is the ability to privately adapt these models with your own data, allowing for customization to cater to specific tasks or align with your industry's needs. Amazon Bedrock emphasizes security and privacy in its design, offering integration with Amazon CloudWatch and AWS CloudTrail for monitoring and governance. This makes it suitable for workloads that need to comply with regulations such as HIPAA, ensuring that your applications not only perform well, but also adhere to necessary compliance standards. Some popular foundation model vendors would include Amazon themselves. So Amazon AI through AWS provides a suite of AI services that are deeply integrated into various models and infrastructure. AI-21 Labs is known for its advanced natural language processing models. They aim to change how we interact with machines by creating AI systems that understand and generate human language in a natural way. Anthropic is an AI safety and research company that focuses on building reliable, interpretable, and steerable AI systems. They emphasize the ethical implications of AI and work towards creating models that can be understood and controlled by humans better than existing systems. And we have Stability AI. They're recognized for its work in developing stable diffusion models, which have applications in generating high-quality images and art. They promote open source and ethical AI, providing the community with powerful tools to create and innovate. So what popular foundation models can we use with Amazon Bedrock? Jurassic 2 is one of the most powerful language models developed by AI-21 Labs. It's designed to understand and generate human language, making it suitable for applications that require natural language processing. This includes tasks like content creation, conversation, summarization, and language translation. Anthropic's LLM. So Anthropic is known for creating large language models that are steerable and interpretable. Their approach to AI is centered around transparency and safety, ensuring that their models not only perform well, but also align with ethical standards. And Stable Diffusion by Stability AI is renowned for its image generation capabilities. It's a model that can create detailed and realistic images and art from textual descriptions. It's particularly valuable for creative applications like digital art, advertising, and video game design. We also have to talk about the Amazon Titan foundational models. So the Amazon Titan text models are suitable for a wide array of text-related tasks such as content generation, summarization, open-ended question and answers, conversational chat, and more. So these generative large language models aim to prove productivity and efficiency by handling complex language tasks. We also have embeddings large language models. So Titan Embeddings G1 specialize in translating text into numerical representation, and these are known as embeddings. These models support use cases like text retrieval, semantic similarity, and clustering, and they provide a method for creating vectors that capture the semantic meaning of the text. Amazon Titan Multimodal Embeddings is designed to handle more than just text. It's capable of understanding and integrating multiple forms of data like images and text together. So this is great for applications requiring search or recommendations or even personalization experiences that consider various types of content. So these Amazon Titan foundational models, which are part of the Bedrock suite, are designed to support a broad range of applications, including those that benefit from personalization features. These models are capable of understanding and integrating various types of data. A key feature of the Titan Foundation model is their built-in support for responsible AI. They come with mechanisms to detect and remove or filter out harmful content. This includes content that may be toxic or unsafe, such as data that exhibits bias or includes inappropriate language. This capability is crucial as it ensures that applications built using these models maintain a standard of integrity and safety that aligns with societal norms and expectations.